Hey everyone, and welcome to this brief overview of this section of videos where we're going to be looking at making a 2D platformer game inside of the Unreal Engine. Now, Unreal is known as being a very kind of powerful, heavy 3D based engine, but it does have some unique features and very powerful tools that also allow us to make these 2D projects inside of Unreal. I have an example here of some in-work projects and even some complete projects that have been made using the Unreal Engine, using the pre-built animation system and some of the level design tools that come pre-packaged with Unreal. So some of the reasons that you might want to use this kind of 3D focused engine to make a game like these that you can see in the background. Unreal comes with some powerful lighting tools. You can definitely implement the lighting effects as you can see in some of the games here, building off of things like normals and getting that normal reflective surface quality that you'd be expecting to see in other 3D games. We've also got things like the Octopath Traveler, which was made again inside of Unreal, and this is leveraging a little bit of kind of the best of both worlds and creating a somewhat unique game that hadn't really been seen before, where it's a kind of 2.5D game where the world is 3D, but everything's working off of 2D animations to get that really original feeling JRPG, but bringing it to a kind of modern and revitalized audience here. Other games are using very similar 2.5D 3D world, but 2D animations as well. Or we've got games, as you've seen here, which are purely 2D, and we'll be looking in this course how we can start getting an understanding of how to leverage some of these systems to make similar games. To do this, we'll be working from an empty project, and we'll be leading up to this kind of complete prototype style vertical slice of a 2D platformer, full with a player animations, some basic enemy AI, all animated as well. We'll have some different interactable classes such as the springs and health pickup, so we have a full health system. And then all of this will be done with a focus on clean, structured, maintainable blueprint code. And just creating this very simple prototype game is going to allow us to look at all of the features that go into the 2D systems, such as the Flipbook Animation system, the Tilesets and Tilemaps, which will be an overview of the inbuilt level design painting system that comes in with the Unreal Engine by default. To try and save everybody a little bit of time, I'm just going to go over a brief overview of what I have here. So I've created a brand new project. I'm not going to go through those steps. I'm assuming that you have some experience with the Unreal Engine, how to get things installed and launch a project. So the project I have here though, if you want to follow along exactly, is a blueprint-based, completely empty project, so no starter content will be needed here. The quality settings have been set for desktop and set to the highest quality, so this should be looking pretty good even though we're working with the 2D assets. Now, before jumping in and getting things moving around and getting our player set up and bringing in the textures and all of those good things for the game, I just want to go through a kind of few housekeeping steps that I tend to take in any new project that I create. So there's going to be a few things that I wanted to set my project to do just for convenience, and I didn't want to do it off screen in case you're following along and wanted the same results. So the first thing I tend to do is we can see here, if we open a new blueprint or asset, by default this will open in a kind of floating window, which can get a little bit annoying. I prefer everything to be docked up here at the top of my screen. So to get this result, I'll show you what we get at the moment. We have a blueprint we can use here, which is the Skysphere, and you can see actually that hasn't opened at all. This is on my second window, so I need to drag this over, and like I said, we get this floating screen. If we want that here, we have to drag that to the top, and we'll have to do that for every new blueprint or asset that we want to open. So ideally, I'd like them all to dock up here by default. So I'm going to go to the Editor Preferences, and then just here we can see the Asset Editor Open location. I'll change that from default, and I'll change this to Main Window. You've got a lot of different options here as well if you wanted to, but I prefer this to just be the main window by default. So this now means that if we don't have anything open at all, we can click this again, and we can see that the Skysphere blueprint is now open exactly where I wanted that. So that's going to be the first thing that I tend to change. Then next, there's just a few other kind of small issues that I find with the default project. So this is a little bit hard to see in the recording. I know I've tried this before, but you can see as I zoom in here, the floor seems to be going from a kind of darker grey to a lighter grey, and the same thing happens. If we press start and look around, we can see some adaptation happening with the lighting here. Now this is the auto exposure. It's trying to recreate what the eyes generally do when you're going from a light to a dark environment or vice versa, and it's a very useful thing to have on, but generally it's something that you're going to want to control in a post-process effect or through your camera directly. And what this can lead to is that you can start creating something in the editor that you think looks pretty cool, and then when you press play, the colors all look saturated and washed out. So to avoid this happening, we're going to want to have basically what we see in the editor be exactly what we see when we press play as well, unless we override that manually in some form of post-process system. So to fix this, we can go to Project Settings, we'll go to Auto, or just search for Auto, and Exposure, so Auto E will bring this up, there's no other results here, so Auto Exposure is what we're looking to turn off, and that now means if we go back in here, even if we get pretty close, we can see that we're not getting that darker colored floor, as that's not what we're going to see in the game. So if we press play, that will now also be exactly the same as it is in the editor. So we now know that if we want our world to be darker, we'll need to actually update that in our viewport just here. Next, we'll just want some of our folder structure set up. So this is going to allow us, if we do this now, we can jump in and just start adding blueprints, bringing in assets, setting up materials, and all of those good things as and when we need them, and we don't need to worry about our project structure, because generally we know that we're going to have a very similar structure for pretty much any project that we work on. So what I'll be doing is in the content folder, which is our root folder, we'll create a new folder named Assets. So this will be where all of our external things, textures, models, anything like that that we might bring in, sound effects, will all go inside of this folder. Now for this set of videos, I know that we're going to need a few different file types. We'll be working with textures, sprites, flipbooks, and different tile assets. So I'm going to create a folder for each of these. The shortcut, by the way, here, if you wanted to create a new folder, is Control-Shift-N. When you're selected inside of the folder you want this to be a child of. And that should do it for assets for now. If we do end up adding anything else, we can always come back and add new folders later. Then back inside of the content folder, we'll also have a blueprints folder. And again, inside of the content folder, we could also do with a maps folder. Now that we have our maps folder, we can also go ahead and save this untitled map. We can see here as untitled. We can press Ctrl and S, place this inside of the maps folder, and we'll just call this main. And this will be our main map that we'll be working from for the rest of the project. Now that also allows us to do something else, which is to set some project defaults, and we'll go into that in just a moment. Basically, we want this to be the map that we load up as soon as we close and reopen the project. Before doing that, we can also set some of the other defaults, such as the character that we'll be controlling in game, and also the game mode, which is controlling the different controllers, the characters and things like that, which will be spawned in, and the in-game logic that will be kind of tracked if we have things like pickups, scoring, or any kind of objective system if you wanted to flesh this project out and take it further by yourself. So to do this, I'm going to go to the blueprints folder. We'll create a new blueprint in here. This is done by right-clicking, going to blueprint class, finding the game mode base, which is going to be the game mode class we want to use. I'll name this one BP_game mode base. So something else to note in these selections of videos, I'll be following the standard Unreal naming convention, so you can be confident that if you wanted to put anything on the marketplace or just work with other people familiar with the Unreal ecosystem, this naming convention should be a pretty good way to get you started. So BP for blueprint _ the name of the class. And just in case we wanted to make any child classes of this game mode, we're going to specify that this is the base or parent version of the classes. And that will make a little bit more sense when we get into the rest of the videos, as we'll be using that kind of hierarchical structure a little bit later. For now though, we can open this, and what we want to do in here is set the default class here that we'll be controlling when we have a character created. Of course, we don't have that character yet, so we're just going to go back into the blueprints folder, right click again, create a new blueprint class, and we want to find the type of character we can control. So we have a couple here. The base controllable ones, we have the pawn or the character. Now, neither of these are really created specifically for 2D characters, and we actually have a class ready for that inside of Unreal. So if we type paper, basically everything we'll be using is part of the paper 2D system. So we've got Flipbooks, which will be our animations, sprites if you want something which doesn't animate. We've got things like Tilemaps and train editors, and then we can see down here we have a child of the pawn is the character, which is just a controllable pawn with a few extra things such as the capsule collider, and it expects a skeletal mesh and things like that. And then we have the alternative, which is the paper character, which is the child of the character class. But instead of having a 3D skeletal mesh, it predefines some properties such as a 2D paper flipbook, which is exactly what we want. So we're going to select this one. We'll call this one BP_player base. So again, if we ever have any kind of alternate versions of the player that we want to potentially spawn in, then we can make those a child of our base class. All of the basic logic, though, will be in our player-based class, such as the movement, health variables, and things like that we can put in here. So with that, we can have a quick look in here, but there's not very much we can see at the moment. We don't have any sprites or flipbooks that we can assign. Like I said, this is going to be controlling the animation, though. But what we have is a capsule collider and a character movement component, which is going to allow us to very easily set up the movement for our character class. So with that ready, we can now go back to our game mode. We're going to go to the default pawn class, and we'll change this to the BP underscore player base. So this won't do anything at the moment. If we press play, see over here, we're still getting the game mode base. So this is not using ours at the moment, which means we're also getting the default pawn, which if you've never seen this before, is the gray sphere. So if you ever see this, this is the default pawn, which means if you're not expecting this to be used, it means you've probably missed a step somewhere and you haven't selected your custom class to be selected. And this gives us that kind of flying around spectator mode type movement. So what we want to do is go to the project settings. We want to set the game mode to be the default, the one that we've created to be the default for the project to use. We do that through the maps and mode section. We're going to go to the game mode base here. We'll change this from game mode base to BP underscore game mode base, which is ours. We can see that automatically knows to use our player as the default player. And now if we go in and press play, the difference here is that we don't have any movement, because to the right hand side we can see we're using the BP underscore game mode base, and because we have a player start in the world, it's created the BP underscore player base at that location. So I'm just pressing F8 here to eject from the player, which allows me to fly around. We can see that has changed to possess here, and we can see that we have the player base at the start of the level. And the reason we can't move this around is because we haven't put any code in our player class to give it any understanding of what movement is. You can see it has things like gravity already processed here though, so if we possess, we're always going to be on the floor at the moment. But that's a good start. That now means that when we do start adding that code to our player class, the project knows to select that as the default class to try and possess and run the logic through. With all of that set up and out of the way, we can now go and start providing some kind of visual reference for our player. So inside of the player base, as we don't have the flipbooks or the animations ready yet or imported from our textures, I'm just going to add a simple cube component to begin with. So if we go to add components, go to cube, this is just going to be a static mesh to at least kind of visually represent where the player is going to be. And this means that we can start looking at the camera setup as well. So for the camera, I'm going to use something first of all called a spring arm component. This is going to be like a camera boom. It's a long stick, essentially a virtual stick that our camera will rest on. We can see that's represented here, so the camera is going to be at the end of our stick, and this just gives us a little bit of flexibility with how far away the camera is going to be kept. It has some built-in functionality for us to animate it or different types of camera lag to get a slightly more dynamic feeling camera system. Now I've just noticed that I still had my cube selected. I actually want this to be a child of the capsule component, so I'll drag and drop that on the capsule component just so that we follow the rotation of the capsule and not the static mesh if we do anything to that. Then with the spring arm still selected, I'll go to add component, find the camera, and then we'll place the camera component on the spring arm. So now wherever we take the spring arm, the camera will follow. So if we rotate this or move it around, the camera is attached to that arm. This just means that we have to do a lot less with the camera as well. We're not going to be rotating it or accidentally doing things with the camera that we didn't want. Now, because we have this, we can see that inside of Unreal, X is always forward, X is left and right, Y is forward and back. So we actually want to be moving left and right here, as obviously in a 2D platform where we're going from left to right, Z up and down, and as I said, Y forward back. So that means the camera is currently looking in the wrong direction. At the moment would be looking from the back of the character if they're facing towards that arrow when we bring in the animated flipbook. So what we want to do, we can get our spring arm, and this is one of the first things we'll see is quite useful. We can rotate the spring arm 90 degrees. The camera's going to follow that, and we're now looking at the what would be our player animation front on. Now, this is also going to be a little bit close. I imagine if we press play, it will default to using that camera. I imagine we're going to be looking very, very close at our cube. So what we can do is we can come here, grab the spring arm. We're going to up this target spring arm length to around about 600. And that means that when we press play now, we can see a little bit more of the level as well as just the player. I'm going to ignore for the time being that the capsule component's a little bit off. We won't be using this static mesh for very long. It's purely for demonstration purposes when we're getting the base part of the camera set up, but I think that's going to be good for now. Next, we're going to want to set up our project input, so the bindings to our keyboards and gamepads, so that we can actually get our character moving around. To do that, we're going to go to our project settings. We will navigate to the input section, and just here we have two options. We have the action mapping and the axis mapping. So as a quick overview for those of you new to the engine, the difference here, we have action mappings would be things like single press inputs, such as jumping will obviously make you jump once, or interaction keys like press E to pick up would be an action mapping. It's something that you press and release, and generally it's a kind of on-off switch. You then have axis mappings, which will provide a value returned based on whether the input is pressed or not pressed. So if nothing is pressed, it's constantly returning 0. If you have it fully pressed, such as a key is either on a keyboard is either pressed or never pressed. So if you have the key down, you're returning 1 or -1. And then we can also work things in like analog sticks, which have a range. So it'd be between -1 and 1. So if you're only pushing the analog stick kind of halfway forward, then you'd be returning a value of like around about 0.5. So again, this will all make a little bit more sense when we go into this in a moment. We're going to have just a very few different inputs for this game. We're going to want our character to jump, so we're going to have a jump input mapping, and we're going to want them to move forward and backwards or left and right, so we're going to have a move right axis mapping. So if we do the action mapping first of all, we'll add a new action mapping here by pressing the small plus icon. We'll drop this down and we'll name this one jump. Now for this, we're going to say jump is going to be, we can add a lot of different buttons here to manage just a single input. So this is going to be useful if you wanted to make your input settings a little bit more flexible. So as an example, we could say for people who use WAS and D, we could have W as one option for jumping. For those who still like to use the arrow selection, we could use the up arrow on the keyboard, also for jumping. For people familiar with the space bar, we could use space for jump. And we could also say we'll account for gamepads as well. So we'll use the gamepad, and these are going to be the face button left, right, bottom, and top will be X, Y, A, and B, or triangle, square, circle, and X, for example. So that's if you just visualize where they are on the gamepad. I'm going to go with the Xbox control scheme. So we're going to use A, and I want A to be jump, which will be button bottom. So that will be the gamepad. So we can now use A as the gamepad jump as well. So that's our jump input. So now if we press any of these and we assign this to the jump functionality in the character class, we'll get our character jumping around. Next then, we want to allow our character to move. So we're going to add an axis mapping. So the axis mapping, as I said, is going to return a value. So we can see the difference here is these are just single presses. We can add combinations, but it doesn't return a value. Whereas for the axis, we're returning an axis value. For this one, I'm just going to call this move right. And we'll actually only be creating the move right function, and you'll see why in just a moment. So what we're going to do is for the moving left and right of the character, we have a positive value. So let's say we're moving we want the character to move right across the screen, which will be our positive value. We'll assign this to D for the WASD input. So we'll find D on the keyboard. So that's our basic right movement here. Now we also want them to be able to move left. So we're going to add another input binding, and we'll find this one as A. And once we've defined the A input, we want to change that scale to -1. Now the reason being is that we're going to be moving in a positive value across the screen to move right, and we want to move in a negative value across the screen to move left. And that's why we don't need a move right and a move left. We can just create move right, which will be the positive assignment, and then it's kind of taken or intuited that move left is the negative value. And then we can do the same thing as we had for the jump, so we can create a number of these for the arrow key, so right arrow. When we've got the right arrow, we can again make sure it's positive, and then left is going to be our -1. And we can assign some analog movement as well for the gamepad. So we'll drop this down, and we've got the gamepad left thumbstick is the one we want to use. In the gamepad world, X is left and right, Y is up and down. So we want the left thumbstick X-axis to be controlled here. Now remember what I said, that the axis value is returning a value of either -1, 0, or 1, or between that range. Now when the analog stick is unmoved in the middle, that's going to be 0. If the user pushes it to the right, that's going to be up to a value of 1, and if they move it left, then that's going to be down to a value of -1. So this scale here actually accounts for all of that, depending on the way that the player is moving the analog stick. So that is everything ready for the move right functionality. So if we move on back over to our player base, we'll move into the event graph, and we can do a little bit of tidying here. So we might need this a little bit later for the begin play. We can get rid of everything else for now, though. We won't need the overlap or the event tick at the moment. And rather than dumping all of our input bindings into the general event graph, what I'll do is In the section over here, I'll create a brand new graph. I'll name this one input, and we'll put all of our input related things in here. Now remember the names that you've just called your input settings here. So we've got jump and move right, because we're going to be calling those in just a second. So to get that move right function, we'll just type move right. And you can see we have two options. We have the axis or the event. So if we start with the event and search again for move right, and then get the axis. Just something that can confuse new people here a little bit. Basically, the axis is the value returned when you're pressing something. So like I've mentioned, -1, 0, or 1, or in between that. And then the event is the option which gives us the execution pin, so we can run some functionality off of this. So let's do a quick print string to see what this is doing. And we can print the axis value. So if I come and compile that, press play. When I'm pressing nothing at all, we can see this is running constantly. So it's kind of like an update function or an event tick. When I press D, which is my right movement, then I get 1. When I press A, I get -1. Same for the right arrow and the left arrow. We can see that's all updating. And that in the most simplistic form is how the axis binding works. So I'm just connected a gamepad here. And I'm now moving the left analog stick slightly to the right, and we can see we've got that value between 0 and 1. And then if I move it left, we've got that value between 0 and -1. So this is how we're going to be driving the movement of our character in a moment. Now, what I wanted to demonstrate, the only difference here, the axis value is exactly the same as the return value from the get move right value here. The only difference between the two is whether you need just the value for a calculation, like so, or whether you need the event for the execution pin to call another function. So we can see I'll use this again, and we get exactly the same options or responses. We get 1 when I press D, -1 when I press A, and I'll get the control pad again, and we can see we've got that value depending on which way I'm moving the analog stick. So exactly the same thing. This is just nice and handy if you're using a calculation and you're trying to get the velocity multiplied by the direction or something, and you don't want to have to call the event. You can just check the value being returned from that input mapping. So with that done, kind of have a better understanding of what this is doing. What we can do now is from this, we will call our add movement input. And this is really as difficult as it is to get a character moving. This is taking some inbuilt functionality from the player class and the character movement component. And it's basically just going to add movement in a direction that we give it based on a scale. So if we say the scale is set to a permanent 1, that means we're going to move in a certain direction, a positive value constantly. So we know we want to move left to right, and we're going to say 1 on the X, because remember, we've already seen that the X-axis is this red one, and that's the way we want to be moving. So just here, Y would be forward and backwards. We don't want to go in and out of the background. And Z would be up and down. We don't want to go up and down unless we're jumping. So if we press play now, that's going to move 1 unit in a positive value on the X, because we've hard coded this to be based on our direction multiplied by the scale. It's going to be moving constantly in that direction if we don't change that. So the way we're going to alter that, you may have guessed already, is based on the axis value, which means if we now aren't pressing anything, we're obviously multiplying that by 0, which is going to stop our movement. If we press D, we'll move right. If we press A, we'll move left. Same for the arrows, and again, same for the analog stick. So really that is as difficult as it is to get movement going on a character. Now this is a little bit magic because there's a few things going on in the background here. So you may be wondering why such a low value like 1 is making us move relatively fast. Based on the direction we want to move it. Now the reason that is we're not actually moving 1 unit. In the character movement component here, we're actually moving 600 units. So what this is doing, in a very simplified form, there's a lot more going on in the parent C++ class, but to get the basics across, what's happening is we're multiplying the world direction by our walk speed. So we're actually moving 600 units multiplied by the scale value. So we're taking our value of 600 and we're saying that if you're not pressing anything, then multiply that by 0, which is again cancelling out movement. If you're pressing D or whatever is assigned to move right on the positive value, then we're multiplying 600 by 1. So we're moving 600 units in that direction. And if we're holding a negative value, so A or left, then we're multiplying 600 by -1, and that will get us moving in a negative value or left across the screen. So just to let you know, there's a lot to look through here if you wanted to play about with different things, and to confirm that that is what is being controlled here. If we lower this to something really slow like 50, then we can see that the movement is completely hampered by that change in speed. So there's a lot that you can play around with here. I won't go through all of this. I think a lot of the naming is fairly kind of common sense, and if you look through it, you can see what it's responsible for, and that will definitely be something to play around with between videos and just get a better feeling of what the character movement component is doing. You do have a lot of flexibility using this. You can do things like changing the acceleration, so you can make it take longer if you wanted to have like a build up to that speed. 2048 is pretty much 0 to full speed. If we lowered this to something extreme like 512, then again you're going to see a big change in how long it takes us to reach that maximum momentum. So you could have like I suppose that would be your old kind of Sonic game where you'd have the jogging animation leading up to the running, leading up to the sprinting when you reach that full 2040. So that is the max acceleration. Again, I'll leave that the same for now, but you can tweak all of these different values and really change the way that your character feels to move around. Now, the final thing for the input then is we're going to add our jumping input. So again, very simple. We want to call the name of that action mapping that we made earlier, quite simply jump. You can see there's actually a lot of different returns here for jump, and that's because there's quite a lot built in to our character class that will allow us to alter how we jump and how that reacts. But we want our action event jump to begin with the one that we've created in the input bindings. And you can see again, this is slightly different to the mapping, the axis map. The main difference is that we're not returning a value. So like I've said, this is either pressed or not pressed. So when you press W or the up arrow or A on the gamepad, this will be called. And when you release it, this will be called. So you've only really got these two states. Now, again, quite simply, there's all of this functionality already built in. We're going to pull from here and we're going to call the jump function. So we have a function here called jump. This is through the character class and has, again, some magic kind of going on under the hood, but it's just applying force in the Z axis for us. So if I come in and press W, then we jump. Same for up and same for A on the gamepad. Now, because this has some stuff ready for us to kind of manipulate and play around with, we can come here to the player base, search for jump in the details panel here. And we've got a couple of different things we can change. So we can actually change the jump count. We can set this to a maximum of 5, and we can get this doing a synctuplet jump. Of course, if you just wanted a double jump, we have 2. So you've got a double jump, so super easy to already get a double jump implemented. And then we've got the max hold time here as well. Now this is going to be relevant to the next part. Something we want to do if we're going to use the base built-in jumping system, whenever we release this, we also want to call the stop jumping. So this will update that parent class was checking all of this, and it will update the system to let it know that the jump button has been released, which then comes into this jump hold time. So if you played games like the old Sonic games, Mario games, or modern platforming games as well, they'll have something that a lot of designers will call variable jump height. So if you hold the button down or if you just tap the button once, you'll reach that minimum jump height, whereas if you hold it for a certain period of time, you'll reach a slightly higher peak in your jump, like so. So again, very flexible system, ready to go inside of Unreal. We have this already accounted for. At the moment, we don't have that variable jump height. We're going to get the same thing regardless of how long I hold this, because we've got the max jump hold time set to 0. Now, if I put this to something extreme, like 5 is way too high for this. But if I put it at that, for as long as I hold it up to 5 seconds, jump force is being applied here. And the way that we would use this, so the player has a little bit more control, is that as soon as we press this release and stop the jumping function, this will be triggered and we're going to break out early and not reach that peak. So I've got up to 5 seconds to hold it, but you can see if I only hold it for like a second, we'll then start jumping or falling back down. If I hold it for longer, then until I release it, we're going to get that variable jump height. So always remember, for reasons like this, because things are being done under the hood that you may not see, you want to remember to always call your stop jumping when you're calling your jump function if you're using the built-in functionality. I'll turn this down to something a little bit lower, like I think something like 0.25 usually works quite well for a variable jump. It's not going to be a huge difference, but it does give that player a little bit of that feeling of a little bit more control over the way that they jump, and allows them to tackle different kind of obstacles in different ways. And I think for this game, I'll make it a little bit more difficult. We'll turn the maximum jump count down to 1. Don't really think we need a double jump for this one. So again, just to come and test this, this is working with all of the inputs, and I have the movement for the gamepad jumping with A, and again, we've got that variable jump height if I hold it down. So some nice systems here to get started with. It's pretty clear what these are doing, but just to get into that kind of good programming practice, we can throw a few comments around these. So if I select the nodes, press C, then we get a comment. This one we'll just say is controlling the directional movement. And we'll do the same again. So we'll select these, press C, and we'll say this one is controlling the jump. Now, it may seem quite obvious, but the way that the comments work is very handy. So even for things which are very obvious, when you've panned out a lot, you're not going to be able to see the name of the events, but the comments do scale based on the zoom. So it can be useful just to put comments in like this, even if they're very simple. So if you ever wanted to dive straight into the jump section, you've got loads of nodes everywhere, and just home in and find the jump very, very quickly. So with that done, we can compile and save that. That's pretty much the basics of the player movement. With some of the fun stuff already implemented, we can now get to working on the visuals, so we can start bringing in the assets, specifically the textures, to start changing up the player so that we can actually see a little bit more in scale how it's going to look and how it's going to be represented in game. Now for this, I'll be using a free asset pack that you can get from itch.io. It's called Pixel Adventure. There's also a Pixel Adventure 2. It's made by Pixel Frog and it is completely free to download. Of course, if you enjoy the package and you wanted to support their work, then I'm sure they'd more than appreciate some small or larger donations if you're able to do that when you're downloading them. Now, I'll also provide some downloads which you can get from below, which have all of these assets, or some of the assets, the ones that we'll be using specifically for these videos, which have been kind of repurposed and altered based on the scaling and things. And I'll explain that in just a moment, why I've made those changes. But if you wanted to download these, they do come in a very small size, which is part of what I would class as a little bit of the problem when working in an engine like Unreal. But again, hopefully you understand the process of downloading something from itch if you wanted to get the entire pack as it comes here. Otherwise, look below to get the download for the project files to follow along with the videos in the same exact way. So what I'll be providing are these. We're going to get the bat, the hearts, 2 forms of player, although we'll only be setting up the frog, the spring, and the level pieces. Now these I have set up in a particular way so that I can show certain different approaches to extracting these, animating them, and getting them set up in a project. And also these have been resized. So this is the way that you'll find things are downloaded if you get it from the itch webpage. So these are the ones which haven't been touched. We can see that they are 32 by 32 pixels. If we look at the jump animation or the double jump animation, we can see they're a little bit small. And if we start trying to increase this, then we're going to get that blurry effect. Now I've increased the size of the assets that I'll be using, that I recommend following along with, in a way that doesn't do this, which is basically running it through a 2D package like Photoshop or Krita. I've chosen to increase the scale by 400% and making sure that we set the algorithm to nearest neighbor, which means you'll get the scale increase based on the pixel percentage and you don't get any of that kind of smoothing around the edges, so you still get a pixel perfect kind of image. Now the reason for this, a couple of things I wanted to mention. First of all, this isn't a very optimized way to bring things into an engine like Unreal, because Unreal will try to compress things. It will compress the image sizes for performance later, only if you provide it in a power of 2. So that is something like this, where I've put them all together in one big tile sheet. You can see it's 1024 by 1024 in dimension, which is the power of 2, so 512 by 512, 256 by 256, and so on. And because of that, it's able to take these assets that I've done that with, and it will try to compress them if they're in that power of 2. So it probably won't do it with these, but like I said, this is more for demonstration. I wanted to show a few different ways. In case you do get given assets like this, it's not the end of the world, it's not going to break your project, and it will be useful to know how to extract things in this way as well. So that's the first thing I've changed, is where possible, I've made them a power of 2 sprite sheet. Now the other thing is obviously the size, and the reason I've chosen to go for the bigger size, so rather than getting the 32 pixel by 32 pixel, we're working more with 128 by 128 per grid space, so per image. And the reason being is that this will avoid us needing to override some of the project defaults, such as the AI navigation search volume. If you consider that nowadays we're working with things like 4K resolutions, you'll have images which each individual image could be 512 or 1024, even 2048 by itself to get those high res images. So working with something which is only 128 pixels per image is still going to be relatively small, definitely not going to be game breaking. We can see this entire sprite sheet is only 31 kilobytes in size, and this means it's going to be much easier to work with. We won't need to change the world sizes. We can still work with a centimeter by centimeter world size. We won't need to override any of the AI systems as well. So I think in this case, working with a slightly bigger image set is going to make things a lot more convenient. So as I've mentioned, if you can, I would definitely recommend following along with the assets that I provide here. Download these. Once you have these extracted, go back into the engine and we'll look at getting some of these textures into the engine and working. So we can do this a number of ways. The thing that we're going to be importing is a texture. So we're going to go to the texture folder. You could navigate to where you found or stored them on your system, go to Import Game Assets Textures, which is going to be the location, and you just find them and select them all and choose Open, and that will bring them in. Another way is to just have the window open here. We can drag select all of these and just drop them into our project. So they're looking a little bit off at the moment, but that's fine. We'll be fixing this in just a second. And what we want to do, in fact, first of all, if we open one of these, we can have a look at some of the settings. So for the most part, these look okay. Maybe a little bit fuzzy around the edges, it's hard to tell, but we can do something to improve this in a moment. So we've got the alpha that we already need here. So the first thing is that this is a texture, which means we can't drag it into the world. We can't see this in the world at the moment. We need something called a sprite to be able to do that. So I'm going to go back to the main textures folder. And what I want to do is we can grab all of these, and basically we want to change the details here and get it to automatically update this to better suit our project. And we can do that by selecting all of these. So Shift and select, right click on our assets and go to Sprite Actions and apply Paper 2D texture settings. Now what that will do, you can see all of the alpha's been accounted for. It's gotten rid of that black background, and just here we can see what's changed is that used to be the default DXT1, and it's decided that user interface would be clear, and I think that does look a little bit sharper. And then down here, the important thing is it's changed this to be 2D pixels. And this works perfectly fine because we're not going for that smooth hand-painted or hand-textured kind of look. The perfect pixel image is pretty much what we want here. And again, I think that started off as world by default. So doing that on all of our assets saves us a lot of time from setting this up manually. Now the next thing we want to do is turn these into sprites so that we can actually start extracting things from them. Before we jump into that, I just wanted to give you a quick example of what I meant by the scaling. So if I start with the hearts, you don't need to follow along here. We're going to do this in a particular way in a moment, but I'm just going to extract the sprites, let it choose whichever option it wants. We're going to go more into the options in a moment. And it's the sprites, not the textures, as I mentioned, that we can drag into the world. So you can see it's actually roughly the same size as this player start. If we press play, it's not too far away from the size of our cube. So this, like I've said, is already kind of lining up with the centimeter-based world scaling options. So I'm just going to get rid of those for now. And in a similar way, I'm going to get rid of the Ninja Frog assets. We're not going to need the smaller versions, the ones which haven't come with the updates already included. We're just going to keep, for now, our textures here. Now, at the moment, I'm just going to get rid of the hearts. We'll probably do the same process in just a moment, but I wanted to go through a little bit more detail on how we can extract these into our game. So the reason that this gets its own topic when it comes to extracting things from these textures is that there's a few different ways that you can do it, and depending on how the assets have been provided for you, which depending on your art team or the project you're working on may not always be given to you in the ideal way or the same way, you may have some issues with how the pivot point is working, which can affect your animation. Now, a perfect example for this, if we go to the player frog, when we want to extract all of the individual images, we go to right click on the texture, Sprite Actions, and Extract Sprites. Now this is what I did very quickly just a moment ago on the heart texture over here, and I just let it choose the auto extraction. So you can see the way that this is working. We have the outline color, which is the outline around every image that it finds based on the transparency around it. So it's going to find every ending pixel and class that as the bound. Now this will extract all of these, so we can do this again. If you wanted to change the naming template, you can change this here, and then each one will be named something like T_playerfrog_sprites, etc. So we can do that, we can see that here, naming conventions. Quite useful because it adds the number, so we know that we've got 25 of these images here based on a zero-based array of images. And what I wanted to show is basically we've got the idle animation, which is these first two rows. Then we've got the running animation. We have the jumping animation down here and the falling animation, or the other way around. So the first 11, so 0 to 10, are the idle animation. So the way that we then make our animation from the sprites is to right click on a selection of sprites that we want to build that animation, making sure the numbering is in order. So this is going to be the start of the animation to the end. So this will automatically put it in the right order for us, and then create a flipbook from this. So nice and simple. Remember, the flipbook is our animation, the sprites are the image that we can bring into the world, and the textures build all of that information. Now if we bring in this animation, we can see immediately there's a little bit of a problem. So I'm going to drag this up, I'm going to press end, so the end key will drop this down to the floor, and we can see that the feet are kind of jumping up and the head is moving down, and that is because it's based on this central pivot point. So it looks like he's kind of floating a little bit. Ideally, the way that this animation was meant to work is the feet stay perfectly still and everything is moving up and down around that pivot point. So if we go in here, we can see again, that's not quite ideal. That's not quite how the animation was meant to run. So we can manually fix this if we wanted to by selecting all of these assets. So again, 0 to 10. We can right click on these and we can go to Asset Actions and then bulk edit via Property Matrix. Now what this will let us do is we can drag and select all of these, or shift and select all of these, go to the sprite options, and remember I said it's because the pivot point is out of place that's broken, because this is going from the center, and because each image wasn't the same size, it was based on where the pixels ended, and obviously that's going to change from image to image. It's kind of confused where that is. So what we want to do is change this from the center to bottom center. Now if we do that, we can see the pivots jump down here, and that is more of how the animation was meant to look. So that's an easy fix. If you do get assets like this, and that's the way you have to work with things, then that's perfectly fine. We've got ways that we can fix this. Just to show another example, we can change this to something like top left, and that will completely break it. But the animation's now playing from the top left of the sprite, so everything's moving up to that pivot point. Okay, so that's one way that we can fix it. Now, I'm not going to keep these because I've actually set this up in a specific way, so we'll delete these for now. If you ever do that type of process as well, make sure that you remove the thing from the world. We still have what is now kind of a null reference to an asset that doesn't exist any longer, so we'll get rid of tfrog from the world. And what I'll do next is pretty much the same process, but I'll show you the way that I intended this to work. So we're going to right click on the player frog again. We'll go to Sprite Actions, extract sprites again. But this time, the reason I've put this in a grid is I've made sure to set up everything. I actually dragged everything 128 units away from each last image. So we can change this from auto to grid, and we can see it finds the entire grid. It's not quite worked out where the images are. And we can change the cell width from 1024, which is the full size, to 128. So we can see we've now separated those off, and then the height to 128. And that will now extract everything at exactly the same size. So we get a little bit of headroom on these, but we can see that all of the feet are being cut at the same place. The animations where the character is meant to be in the air, again, that's accounted for with that same size grid space. The problem with this does come that you get these extra cells. These will be cut out and classed as a sprite. We can fix some of that by the number of cells that we want to cut down to, which I'm going to set to 6, because we only have these 6 that we really want. But you'll see that this also helps us with the naming convention, and we can very easily create our animations by using this. So what I'll do is I'll extract this. So we now have, like I said, this is separated quite nicely. We know that all of these are the idle up to the first empty space. All of these are run up to the next empty space. Then we've got full, and we have jump. So what we're going to do is we'll recreate that flipbook. I'll right click on this, create flipbook. Now I'm going to keep this one, so I'm going to name this one FB for flipbook _ idle, or player idle. Okay, so again, the naming convention for flipbooks is FB _ name of the flipbook. Textures are T _ the name of the texture, and so on. Because there are so many sprites, I'm actually going to get a little bit lazy and not rename these. I'm just going to shift select all of these and drag that into the sprites folder just to get them out of the way. We now know that we can delete these empty sprites as well, and we can just kind of go along in this order, and it makes the process fairly painless for us. Now you can see that because that has the exact size that it knows that each image is, that has actually worked for us correctly to begin with. We're not getting that unwanted falling animation. So next we can do the same thing with our running. So we'll shift select all of these, right click, create flipbook, name this one FB _ player run, and we have our running animation. Now I think this speed works quite well. The first thing that comes to mind here is that idle looks a little bit intense because it's animating so quickly, and it's really just meant to be when the player's doing nothing. So I'm going to change the frames per second from 15 down to something like 8, and that looks a little bit better to me. You can change that to whatever you want it to be, but this is just basically changing the playback rate. So if you want them to be very energetic, then we've got something higher. Or like I said, something a little bit more chill, we can go a little bit lower. Again, we'll drag all of these into the sprite folder. We won't be using these again, but of course they're referenced in the flipbook, so we do need those to still exist. Likewise with the textures, it goes without saying, I would hope. And that leaves these two, so we've got the falling animation. Now this is quite interesting. When you're working with something like this, even as a single frame, we still need to make this a flipbook because that's what our component in the 2D character class is expecting. So we'll call this one FB _ full. And we'll call this one, create this one, sorry, and call this one FB _ jump. Now if we open both of these, I'm just shift selecting and pressing enter, we can see that this is still playing. We can save a little bit of memory, I guess, here by turning this down to 0, so it's not going to loop, it's not going to actually play the animation, but this is now the asset type that we need for these two animations, as they are technically animations. Okay, so that is all of our player flipbooks ready to go. Again, we can grab these sprites and we'll drop that into the sprites folder, and then we can remove all of these empty cells. That leaves us with our flipbooks, so we can move our player flipbooks into the flipbook folder, and that is basically the project setup that we're going for with the structure here. Now the next thing is our mask player. The reason I have this, I just wanted to show another example of where certain things won't work and you need to kind of jump in between. So these have been set up exactly the same way, 128 units apart from each other, but because of the size of this player and the headpiece that it has, if we were to come into the extract sprites option, again, the automatic one wouldn't work here at all because these two, the feet are actually touching the headpiece. So these would always be extracted together and completely break that first setup. So again, although for the frog there was kind of a workaround, for this one there wouldn't be a workaround, and you would have to know the grid scaling and again separate this by 128 on each, and you can see that cuts through just where the foot and the headpiece are kind of touching each other. So just something that I realized was going to be a useful example. Like I said, I'm not going to use the player mask, I'm actually going to get rid of this now, but I just wanted to show that quick example. Likewise, the same thing actually happens with the bat. So we'll do this one together. We'll go to the bat, sprite extractions, and extract this. So again, because these wingspans are touching, it classes these two as a single bat, and then the rest of these are working perfectly fine. So what we're going to do is we'll change this to a grid. This is a complete width of 1288, and we have 7 bat images, so divided by 7, and we'd have a cell width of 184. Should be, yeah, so that would be exactly the amount that we need to cut off. So we can now see that they're not the same size, but that's perfectly fine. Remember, we have those pivot overrides if we need them, but that's now cutting right in between those two wings, going right up to that wing, so that's the size that we need. The height is perfectly fine, 120, it's picked up what the maximum is for all of those. So again, we'll extract these. We will create a flipbook. We'll call this one FB_bat, and we'll just check that that has worked. And in fact, we didn't need to do any pivot offsets there, that looks perfect. So again, move these into the sprites. We can move that into the flipbook, and we're just basically going to do this for the rest of them. So for the hearts, as we've seen previously, this actually works if we just do the sprite extraction, go to extract sprites, and this one will actually work with the auto extract. So we can right click on this, create flipbook, call it FB_hearts, and just double check. That is pulsing from the middle, which is what we want anyway, so that has been set perfectly fine. And the final one, I'm going to choose the option here that we're going to, for the spring, we're going to right click again, we'll go to the extract option, and I actually can't remember if I set this up to be grid based, so we'll have a look into this. I think I might have done. And yeah, we can see that all of these are on the ground. If we do a 128 by 128 grid, it means we just need to get rid of the empty cells, and then we can select all of our spring animation points, create a flipbook, call this one FB_spring, and that works perfectly. So it stays grounded and it does a small pushing animation. So just to tidy up, again, flipbooks in the flipbook folder and sprites in the sprite folder, and you can control click to deselect the things you don't want. Move those in, and we're done. So what that means, we can close all of these windows. We've kind of finished with those, unless you wanted to change the playback speeds. We can now go to our player base class. Inside of this, we want to go to our sprite. And in fact, first of all, we want to get rid of this cube. So I'll delete the cube. We'll go to the sprite. And in here, we can now change our default source flipbook to our FB_, let's say, player idle, which gives us an idea of the size of the player. Now I know that we're going to need to move this up a little bit because of the pivot point isn't quite in the middle of the capsule, so we're going to move that up just a little bit. And then we can grab our capsule and we'll drag the capsule size down, and we want this to be probably just inside of the feet. We don't want it to look like the player's hovering, so we're going to make the capsule a little bit smaller than the player is, so it looks as though it's resting quite nicely on the floor. And if we try this, this should drop into the world. And there we go, we can see that we're moving around. It doesn't look as though we're hovering. And as we get to the edge, that looks about right. So we obviously want to start playing different animations when we move around, but this is definitely a good start to where we need to be. We have the 2D animation system now in, and we can start getting an idea of what it's like being in the world. So this is kind of like what I was talking about in the trailer to these videos. We've got the game Octopath Traveler, which is a 2D flipbook essentially moving around in the 3D world. So we could, if we add new dimensions to this, have a very similar game using these 2D animations, but having this kind of 2.5D or 3D world to interact with. So again, another benefit of doing all of this, although it's not an engine which people really consider being kind of 2D ready or 2D optimized, we do have some pretty cool features that we can make with the Unreal Engine with a kind of 2D hybrid. So again, at this stage, we're getting quite far, and make sure that you're saving your project as you go along to keep all of those updates that we're making. And another thing I've just remembered, if you are closing and opening the project, you are probably being greeted with a new map each time. So what we can do to bypass that for now is go to the Maps and Mode section. Because we have our main map saved, we can change the editor startup map. You're getting the template default, which is just that empty map, similar to what we have, but not the one that we've been working in. So what we can do is we'll change this to main. So now every time we close and open the project, that will default to be the map to open. And likewise, if you ever want to give this to somebody else to play, we can change the game default map to main as well. So again, they'll be greeted with this map that we're working in. And we're going to start making changes to this soon. To make this more 2D based, we'll be using our painted tile map and seeing how all of that works. Before we can get to painting things inside of our tile maps though, we need something called a tile set. And to get those, we're going to once again repurpose our textures. So from the assets and the textures folder, the final thing we haven't used, you may have noticed, is the T_terrain. What we want to do with this is something a little bit more unique. So we're going to right click again. Previously, we've been extracting things as individual sprites. What we want to do with this one is we will change this to create a tile set. Now what this means, you can see it looks pretty much exactly the same at the moment. This allows us to specifically set things like the size of each individual cell, and then give these different cells things like collisions from this option up here. So at the moment, the default tile size is 32 by 32. And for those of you paying attention based on the size of the texture, if you've looked at this isn't going to work. So each of these four basically are meant to be what we select. So we can see that 32 by 32 is a little bit too small. When we're painting things, it's been expected that we're going to be painting things in blocks this size. So what we want to do to achieve that is just up this to 64 by 64. And this is very important that we make this change now, as this will kind of carry across to our tile map when we create that a little bit later. So it's going to save us time and automate the process a little bit. So with that, that means that we now have the correct selection size for all of our different pieces, like so. So that's the first important step. Now, the next thing to note is that I'm only going to be working with this selection up here. If you wanted to make different levels and use these different assets that I've provided, then you can use all of these. Just follow the same process that I'll be making on this selection up here for the different parts down below, and then you can come up with your own creations for the levels with these parts. Now, the next thing is we want to consider then how these will be used in the world. So things like this, I'm going to class this as a bit of background information. So things like the background won't need any collision. It's not going to interact with the player or anything else. In a similar way, we have bits in the middle just here. So these, again, they're likely never going to come in contact with the player. So we probably won't need to add collision to anything like this. The bits around the outside though, so these walls and the floors and things, these will have potential to be interacted with. So we want to add collision to these tiles. Now the way that we do this is a little bit of a repetitive process, but we're going to select each individual tile and we'll see that this appears up here. Now unfortunately, if we select multiple things, that disappears and there's no kind of copy paste that I've seen. So what we want to do is select each bit that we want to have a collision, go to add box, and you can see over here a white box has just appeared around our collision tile, which shows us where the collision is being set. If we wanted to update that a little bit, so maybe that's a little bit too going up a little bit too far, a little bit too high, we can move the arrow around and that will change the size of our colliding box, or we can extend that if we wanted to go past the visible image. Now for all of these actually work quite well if we just leave it very snug around the grid size we have here. So I'm just going to go through and basically select every bit and hit the add box. So that's the first one done. Basically all of the outsides there. I want all of the sides, so these tops and sides, and then all of these individually can have their collision as well. So I'll put that in a kind of sped up montage in the background here so you don't have to watch it in real time and you can follow along and pause it if it gets ahead. Okay, so with everything done, I've given these colliders as well because these can add some nice detail around the edge of the levels that you can still jump up on, just to break up the monotony of just seeing this one bit of land and the border. So the final thing is, once you have all of your collision, you think you have it set up in the correct way, we can go to the colliding tiles option here, and it will actually change everything to be a blue grid based on what has collision and then what doesn't have collision. So we can see that everything that I said would need collision has it here. I don't think the player's ever going to reach this, so probably not worth doing. They definitely won't be able to reach this unless they've gone a little bit buggy. And likewise, this is just kind of filler, visual filler to go in between the different grids when we're painting to make things a little bit more interesting. These will all need collision. They're only really going to be used as like platforms or bricks to jump upon. So that is pretty much perfect. Now, I probably won't use these, but just to show you a final example, we do have these down here. So if you wanted to use floating platforms or something, these probably won't be ideal to use in a tile map anyway, because if you wanted a platform, you normally want to be able to jump up through them, and you cannot do that very easily with a tile map. You probably want to make that blueprint of its own, and you'll set up collision in a different way. But if for some reason you did want to use this, if you just want them to be like a solid bridge that you can't jump through, then again, very similar way, we're just going to add collision here to all of these, and then this is where this comes in handy. So obviously the bridge here, we'll call this a bridge, is definitely too big from the bottom here. So we're going to select this, and we can just drag this up and maybe drag it up just a little bit more. So there's no great way to overlap this. We can change the grid snapping down to something like 1, so we get less of a snap. And there we go, we can go around the outline perfectly, and we'll do that for all of these. So I thought this used to update. It seems to only have information about the whole grid size. I was hoping it would visually represent this here, but I can confirm from previous experiments that in-game it will take the collision from this box size here and not necessarily what you see here. So that now means that if you do add these in, the character won't be colliding until they reach the absolute bottom of this rather than the dead pixel space around it. So that is really all you need to do to get a tile set up. That's ready to go. The collisions are as we need those, and like I said, if you wanted to take that same approach, you can do that for all of the different assets. You can probably already see why I'm not going to do that for all of the assets here for the sake of the tutorials, as that would be a little bit repetitive, and this will be more than enough to show the main techniques and principles that go into creating our tile map. So we can now close the tile set. We've pretty much finished with this for the rest of the course. I will drop this into the tile assets. So we're only going to have one tile set and one tile map, so it's probably not worth having separate folders for them. So I've just created one kind of encompassing a tile asset folder. With our tile set in place and ready to go, we now have the asset that we need to base a tile map on. So similar to with our textures, if we right click on this, we have a context sensitive option, so we can now create a tile map from our tile set. So we can choose this option. Again, this will create a new asset down here. I'm going to go into this and we can see how this works. So the first thing is the active tile set has been automatically picked from the one that we've created a bit earlier. If you had more than one, you could change that here, and it is taking in some information. Again, the important thing, to the right hand side we can see we've got these undo arrows, and the tile width and height has been set to 64 by 64. If we had this by default, it would have been 32 by 32, and like I said, that would then mean that we're selecting incorrect sizes from here when we're trying to paint things. So if we were to come in and select this, we're going to be getting the wrong chunk, as we can see. So that's why it was important that we were using the correct tile width and height to begin with for when we select things from here to paint into the world. So now as I select these, you can see that's changing the paintbrush, and we've got the option here, paint, eraser and fill. So very simple, but you're probably familiar with what these do. And then this white grid is kind of like our canvas. It will be the world that we're painting onto. So the next thing would likely be to change how big we want this to be. At the moment, if we were to, for example, grab all of this, place this in, that would essentially be the size of our world. So let's see how this works. We can drag in our tile map, pull this into the world, and that's probably a little bit too small for the player to walk around on. So if we've got some collision over the camera, we'll sort that a little bit later. What we want to do though is make this bigger, so we can change that with the map width and the map height. So every grid unit here is going to be 64 by 64, as you would expect, and if we drag that along, we can make this much bigger. Now you probably won't want this to be huge, otherwise you have a very big space to fill. In fact, I think something like 60 by 40 might be quite nice here, maybe a little bit smaller. In my tests, I think I went for 80 by 20. So something wider than it is tall. We're just going to make a very kind of horizontal level, and then we can start at least kind of working out how the system works. So the first thing is I'm going to get the eraser tool and get rid of these. And we want to focus, kind of like if you're familiar with Krita or again Photoshop, we have a very flexible layer system here. So layer 1 is the one we have at the moment. We can add new layers to this. I'm going to work with something quite simple. So I'm going to create a background and a foreground level. So the one on top is actually going to be the foreground. This is the frontmost layer, and then we have a background layer. I'm just pressing F2 to rename these and giving those a quick name. Now, as a quick example to show what this will look like, I'm going to get this black color here. So by selecting that, select the fill tool, and on the background, just fill that all in black. And then to test we have the right one in front, let's grab a little bit of hill, change this to paint, and of course, anything that you select is going to be painted here. And we'll just make sure that this paints over the background. So that's pretty much how we're going to be using this. We now have our background pretty much set and ready to go. So everything behind us is going to be that black painted color. And then we can start drawing onto the foreground, which will be the bit that the character or the player is going to be interacting with our colliding pieces. So a few things first of all. These have been given collision for a reason. So I'm going to add these as a kind of outline to the level. So ideally what I was thinking is we would have a kind of corner around all of these. And this is to contain the camera in as well. So the camera is only ever going to see this kind of black outline, which is why I want this to be wider because the camera can see quite far horizontally. So we need a good, I think it's something like 16 units was roughly when the camera would start seeing that there was empty space around it. So we'll have like a corner around about here. I'm just pressing Z to rotate this, and X will flip it horizontally. So I'm going to rotate that, create one there, create one roughly there, and we can just erase that one. And then grab one of these side pieces. Remember, we want the player to be colliding with this stone looking piece here. So again, I'm just going to flip that and we can just paint that down around here. You can use different pieces if you want. They're all pretty much the same though. So I'm just going to flip that to reuse it. And this is basically how we're going to set the level up. So it's just going to be a lot of flipping things, dragging it. If you make a mistake, then we're going to erase that. You can also come in, shift select, and with the paint tool, as long as you've got the paint tool selected, shift select will copy that. And again, we can flip that and just paste these in. Again, making sure you've got roughly a 16-point distance from the edge here, and you should be fine with the camera not seeing the empty space that we're going to have in the background. Because remember, we're still going to have all of this around it in the background. We can simplify this a little bit for the artistic style, but the main thing is that you still don't want to see that kind of too obviously that this isn't the entire world. The next thing, so that's kind of the borders done. We can shift select this as well, and I'm just going to flip that again using Z. That is that bit done. The next thing is we want our hill. So this is pretty much just going to be using this. I've made that a little bit too short. May need to add a little bit extra height to this. We'll see how this goes. So we'll paste this down here. Then we're going to want these to go down to the floor, and you can see this does have a little bit of an outline, so keep that in mind that these should be going along the floor as long as you want them to go, and then this will be joining up with the other pieces, making sure that's a middle piece there because of the outline. And then like I said, this is the bit, this is just filler that the player won't see. And really the artistic style I've gone for is when we want a new ledge, just using a similar kind of setup there. We can paste these along, and another tip is if we select these two to the right and then just drag that along, that end piece will always now be kind of dragged to the very end. So you can see it just saves a little bit of time there from selecting different pieces over and over. We have that flexibility, so I can just paste that in. It does mean that we need that to go down a bit further, get that corner piece, and then we can do something like select the fill tool and fill that in there. So again, you're probably going to want to do something a little bit more creative than I have, so I will not keep this running and do the whole thing with commentary. So you've got the base idea though. We can drag and select different things to have some kind of interesting looks here. Like I said, rather than just having one constant grass level piece, that's how you can kind of fake some foreground and background looks with the different connections there. And then the final thing I'm going to do as well is the area within this kind of bounding that I've made. I'm going to go back to the background area, grab the eraser, and just make sure that we take this out because I find that color does clash a little bit too much with the character outline, and it can look a little bit messy, a little bit confusing, and it's nice to get that nice solid black outline from the character. So I'm just going to erase everything here. That's the only other thing you'll see me do. But the next thing you're going to see is a fade to the final result. If you're in the UK, a kind of Blue Peter, here's one I made earlier kind of effect. Okay, and here's one I made earlier. So like I said, it is very, very simple. I've cleaned the background up, I've added a few different layers of platforms, had some overlapping thing here to show that you can make them look so they're intersecting. All of that is kind of accounted for in the way that the outline's been done here. Added a platform for us to jump up on. I haven't made use of the wooden platform, but you can add that in if you wanted to. And then just a brick down here for us to play around on as well. So that's the final result. You can get something very, very similar to that if you wanted. The main thing, like I've said, is that when we drag this into the world, this is going to account for the what the camera can always see at any point. And we're not going to be able to get higher or lower, and the camera kind of viewpoint or field of view for the vertical side isn't quite as high as the horizontal plane. So if we come back into the map now, we can start seeing how this is going to work. So we're going to drag this into the world. We can see that's much bigger. I'll zero this out, so we can go 0, 0, 0. And because the pivot point is top left, we'll just want to drag this over. And we really want this to line up with the player start point. So I'm just going to drag this below the player start. And we can start getting rid of things like we won't need this floor any longer. We also won't need the reflection sphere or the fog. So we can get rid of a few of the things from the world outliner over here. Now if we press play, as long as that's in line with the player start, the player should fall onto those grids and collide. So we there have something that we can walk around on. We can see there the player's foot is kind of hovering, which is why we wanted to get this in nice and early. We can hop back to the player quickly, bring that capsule component up a little bit more. Like I said, we can make that kind of fake in size and kind of have that inside of the foot a little bit there, so that when we are resting, it looks as though we're resting on the floor. Now, I'm not a huge fan of those realistic clouds in a pixel art game, so what I'm going to do is for the Skysphere, a small tip here, I'm going to make the colors determined by sun, not based on the skylight that we have. So we've got our light source. We also won't need the raycast nav mesh if you have that. Back to the Skysphere. I'm going to set the brightness, cloud speed and cloud opacity down to 0, and the star brightness. All of those won't be relevant, which now gives us a clear sky. I think that's now a little bit blinding, a little bit bright. It looks as though we're actually in heaven or something. So what we want to do is I'm going to change the zenith color to a darker, maybe a darker bluish gray. I'm going to copy that because we'll reuse this hex value in a moment. I'm going to change the horizon color to the same color. And this just gives us a nice kind of flat Skysphere. So if you've ever wanted the Skysphere to just be a very kind of minimal flat color, I think that works a bit better. It doesn't conflict with the outlines, so we can still clearly see the outlines that have been added to all of the assets, but it's also not too bright. It doesn't have the clouds. It looks a little bit more fitting with the art style. And just to test, we can see the camera can't see any more background over here. We're not seeing anything above us, and we're not going to see anything to the right hand side, hopefully. So that's all looking pretty good, and we're colliding with everything that we'd expect us to collide with. With our tile map set and ready to go, we now have something for the player to run around. So we have our play space essentially. What we want to do now is return to the player class, and we're going to go through the movement and the animation setup. So we're going to flesh that system out a little bit more. So back inside of the BP_player base, we want the event tick again. So where possible, obviously we want to try and avoid the event tick calling a lot of functions constantly. Some things like the animation and checking certain states, we will want to be pretty much updated constantly so we get that immediate feedback. So we will be driving this off of the event tick. This is the kind of thing which is going to be so lightweight that it's really not going to add any kind of performance bearing here. Now really what we want to do, there's going to be two different things that we want to be constantly checking and updating on the event tick. We're going to want to control the player's animation based on the current movement status whether they're in the air, in the ground, idle, moving, and so on. We're also going to want to update the player's animation based on the direction that they're moving or the input that the player is pressing. So to do this, because we know we have those two main things we want to check, I'll run this first of all off of a sequence. So basically we're going to have our movement sequence and our rotation sequence. We can add a reroute node here if we wanted. Sometimes it's nice to kind of self-document as you go along, so we know that when we come back, we'll leave a comment here and we'll say that this will be our rotation. So a nice simple comment just to remind us what we're doing as we go through. For the movement though, this is going to be the animation based on the movement. This will be the slightly more complex thing. I'm going to run through this in two stages. We'll be fleshing out at this stage the very basic rudimentary implementation that we can get into the event tick so that we can very quickly visualize what's happening. And then we're going to go back a little bit later and we will refine this with a slightly better approach. But I wanted to show both approaches so that we can see why one will kind of automate the task for us a little bit better. So to begin with, what we want to do is start checking all of the possible states that we can be in regards to how the player is moving around. So first we can run this off of an initial branch, and this will be checking whether or not we are grounded. So the character movement component has, again, all of this kind of tracked for us, and rather than grounded, we're actually going to check whether we are falling. Same sort of thing, but kind of reverse logic. So it has a variable being tracked whether the character is currently in a state of falling, so whether we're in the air at any given time. If we are, what we want to do is grab our sprite, so our animation that we have going, and we're going to set the flipbook. Now we want to set the flipbook to a certain state, of course, when we're falling, so moving in the air in any way. We'll start by assuming that we are jumping, so we'll change this to FB_jump, and we will plug that in here. Now this is really going to cause a little bit of an issue because we've essentially got two states we want to account for, whether we're moving in a positive vertical value or a negative, so whether we are kind of reaching that apex of the jump or falling back from it. Basically anything when you're not on the ground is classed as falling, so this isn't fully what we need at the moment, but this is a good start. Now, because we will be reusing this quite a lot, I'm going to grab from the flipbook here and promote this to a variable. I'm going to name this one FB_jump. And we will need all of these as variables as we go through. This is a nice easy way to set this up because now that we have that set in our slot, you'll see that it automatically assigns the FB_jump value to the jump animation. So we'll go through this step by step, and this will kind of flesh out some of the variables that we need as well for when we return and tidy up this logic. So we're going to do another branch check here. And we want to find out if we're on the ground, so now assuming that we're not falling or rising, and again we will return to that a little bit later and flesh this out. We'll do the ground stuff first of all though. We will now want to know whether we're on the ground and we are moving side to side or if we're completely stationary. So quite simply, we can use the getVelocity call here. So we can find the velocity that the character is moving in. We want to check whether or not this isn't equal to, so we'll get this as a length to make sure we account for any of the directions. So this will return the vector essentially as a float, and basically this will know that if we're moving left, right, forward, or back, up, or down, if this returns 0, then we'll know that we're not moving in any direction whatsoever. So we can say isn't equal to, so if this float isn't equal to 0, then we know that we're moving, so this will be moving or not moving. So again, what we want to do from here, we're going to have to grab our sprite and flipbook, so I'll Control W to copy this down here. And we'll do this again, so Control W as we'll need to do this a third time, and hopefully you can start seeing why this isn't going to be the most ideal setup. We need to keep calling this one function over and over. It's kind of replicating logic, and again you'll see how we can fix that quite easily in just a moment. But first of all, we'll get things that are kind of going visually. We can actually start testing this as we go along. So at the moment, because we've got this set to nothing, we need to do a few more steps before we can test. But if we were to jump, we can see that we get the jump animation. Anything else is going to set this to be invisible. So what we're saying is that if the velocity isn't equal to 0, so if we are moving, then we're going to want to set our flipbook here to be run. So we'll set this to be the running flipbook. We'll promote this to a variable again. We'll call this one FB_run. And we're going to do something very similar down here. So this one is, of course, if we're not moving. So we're going to set this to FB_idle, or that is player idle. Just noticed a bit of a naming issue that I have there, so I can go back and fix that a bit later. I'm going to promote this again to a variable, and that will be FB_idle. So now we've got something which is filling those slots, so we can now test this. So we have our idle animation if we're not doing anything, jumping animation if we're in the air, and running animation when we are not stationary. So of course we've not accounted for the rotation. We haven't accounted for the jumping and falling, but they will be coming up very shortly. So for the jumping and falling, I'm now going to introduce you to the select node if you haven't seen this before. Basically, what we want to do, if we know that we're in some form of being in the air, we don't know whether that is a positive or a negative speed that we're moving yet on the z-axis, what we're going to do is we're going to unhook our FB_jump, and we will select a flipbook depending on a certain result. So we're going to get our utility select. This is taking in a wildcard. We can change this to a few different variables by default. And we want this to be the return of a Boolean again. So we're going to do a quick Boolean check. We can copy our get velocity down here. We're going to check on this in a moment. We can split this. We're only interested this time in one of the axes velocity, so we'll split the structure pin. We want to know whether we're moving on a positive or a negative value in the z-axis, so up or down basically. And what we'll do is we'll say that if this is less than or equal to a certain float, so we're going to account for the exact point we hit the apex, then we will pass that into our wildcard. That will change that to a Boolean, and we now have a check to find out whether or not we're moving vertically in a positive or negative value. This is really good because we know that this is a Boolean. We get this changed to true or false. So if this is true, so if we are less than or equal to 0, that's true, then we know that this is going to be our falling animation. And that one's named terribly. I'm going to go back and fix these now because that is worse than I expected. So FB underscore fall, that should be player fall, and FB player jump. Okay, so that's going to make it much easier now to find in a good order here. So what I was saying is that if this is less than or equal to 0, if that is correct, then we know that we're falling. If it's false, then we know that we have a positive value and we are still jumping, or we haven't yet reached that apex. So we can press play here. We'll double check that this works. So we've got jumping and falling, and that seems pretty perfect. So it just gives us that kind of better ideal of which way the player's moving. It gives us a little bit more of that visual feedback. It feels a bit more polished immediately that we know in which direction we are moving vertically. So I'm just going to plug this back into jump, promote this one to a new variable. And I'm happy shorthanding these names because we're in the player class. This is kind of obvious what this is going to be. The naming convention here is more so that it all lines up in a nice, accurate way in the content browser. And it's easy to find, as you saw from the list options then. That is the movement setup. This is the quick, kind of dirty approach to getting the movement going. We've now accounted for pretty much everything we have an animation for. So jumping, falling, moving, and idle, they're all in here ready to go. To finish this off, we want to address this rotation comment down here. So I'm going to move these up just a little bit, just to give us a little bit of space, and move this down a bit more. For the rotation, what we want is our sprite. Basically, there's a few different ways that we can do this. We could invert the size of our sprite. So facing right would be positive on the scale X here, and -1 would essentially make us flip. Now, if we have anything which is attached to our character, if anything has like a projectile point or a power-up that we want to throw, this could get confusing because the power-up's still going to be here. We'd also need to account for that, and it could also change the scale of things which are being spawned. So generally, I'm going to avoid doing this, kind of the more simple approach, I suppose. Instead, what we want to do is we're actually just going to completely rotate them around, and we can see with this that we want to do that on the Z-axis. We're affecting the yaw of our character rotation. So I'll set this back to 0 by default, just so that we have like an idea now of what we're aiming for. And what we can do this driven by either our input. So we already know that we have our move right axis, and we can check whether this is more than or less than 0. If it's more than 0, we're pressing right. If it's less than, we're pressing left. The issue of that is that if we change this whenever the player presses a button, it could get a little bit twitchy if the player is pressing constantly. So instead, I'm going to drive this off of the velocity again. So we'll only change this to match how the character is moving in the world. So like with the vertical velocity, we can split this as we're only interested in the X movement speed that we have here. I'm going to pull from this, and we will use a compare. So we can get the compare float operator here, and this will be executed. We can run this from a reroute node to keep this tidy anyway, so we get a nice line here. And in fact, I'll do the same up here, as that's now taking up a bit of space. So I'm just double clicking now. If you're not familiar with that, double clicking on a wire will give you a reroute node. And what we want to do is basically we can check if this is more than a certain value. So if it's a positive value, we're moving right. So we want this to face forward. If it's a negative value, then we're moving left. So if it's more than 0 or less than 0, which is our compare with value here, then we're either moving in a positive right or negative left direction. So with that known, we can now set the rotation of the character. Now the safest way to do this, because the player controller is tracking a lot of our rotation updates, we want to get our player controller, and we want to set the control rotation of this. So this means that because we already have a class which is kind of overviewing and watching the rotation setup of the class, rather than having any kind of conflicting logic against that, we can just use the information which is already being tracked in our player controller and update that. So I'm going to split this and plug this in here. Now, remember we wanted to affect the yaw, the Z rotation. The default, so moving right, is correct as it is, so we're going to leave that as 0. We can copy this down here, and we can set this to 180 if the character is moving in a leftward direction. So we can test this again. So if I move right, that is happening as we'd expect, and left, that is flipping absolutely everything. So that's a problem with the camera, but that does mean our logic is working. So we're going to go back to the spring arm. Basically, this is happening because, like I've just mentioned, all of this is being checked and updated in the controller. And that can also include some of the camera and spring arm setup. So basically what's happening, if you're not sure at the moment, is as we press left, the entire actor is being turned around. The camera is still facing in the same direction, but we're now looking at this from behind the tile map rather than in front. So to stop this happening, we're going to grab our spring arm. We will change this to use the pawn control rotation. So again, this is another benefit of using this player control rotation because some things within our pawn class will be able to reference this. So we now want our spring arm to inherit the same rotation as the controller's tracking, and that means that we don't need to worry about inheriting any of the pitch, yaw, and roll. So basically what this meant is if we have these ticked, whenever the component that this is placed on is being moved around, rotated or anything. So as a quick example, if we bring this into the world and I'll press F8 here to zoom back out, we can see here the camera is inheriting the rotation if we move this around. So we don't necessarily, and this would also be if you were kind of rolling your character, if you played an animation at some point, you of course don't want that spring arm to follow the same rotation that the character's taking in all of these potential different directions. We always want this to be facing straight on. So what we're going to do is we will untick all of these and make sure that it follows the pawn controller rotation. So that means now that if we press play, you can see that we can turn and move left and right, and the camera's still facing forward because it's updating correctly through the player controller. We have all of our animations going as we would desire. So the final thing, just to tidy up the code, is I'm going to come in, get rid of that comment, and what I think we can do is we could do with putting these in their own functions. So this is taking up a bit of room, and we can potentially save a little bit of performance by dropping these into functions as well. So we're going to make use of that. What I would do is grab all of these nodes, so regarding the movement and the animation, and we'll right click on one of these nodes, we'll collapse this to a function, and we will call this update flipbook, as that's really what this is responsible for. Okay, so this is where all of our flipbook logic's going, and we can see that's now saved us a lot of space in the event graph. Likewise, we can do the same here, and we'll change this to update player rotation. So by collapsing that into a function and naming that one update player rotation. And again, just a little bit of tidying so that this is nice and easy to read. We probably won't need these reroute nodes, so I'll just get rid of those. And with that done, we can see we've saved a fair amount of space here. And now it's going to be very easy to jump back through our code. If we want to update the animation, as we're going to do in a moment, we know that we need to look in the Flipbook function. And if we ever want to change the way the rotation is working, we can jump straight into our rotation section. As I mentioned, the Flipbook animation update hasn't been done in the most ideal way. This is very kind of manual on a per basis situation. We have to keep calling this same function, and again, that's not really ideal either. So what we're going to do is try and automate some of this process with something called an enum, or enumerator, if you've not heard that term before. It means that we can create a different value, which can be tracked and represented by integer values, so it's very easy to iterate through, and we'll have one enumeration state for each of the different states the player can be in. This means that we can store a state for the player based on what's happening and set the Flipbook animation just once based on the state we're currently in. Again, as with anything, if you haven't seen this before, it will make a lot more sense as we go and create this now. So let's go back into our blueprints folder. This is essentially a type of blueprint. We find this by right-clicking, going to blueprints and enumeration. I'm going to call this one E player movement. Notice here that there's no underscore. The naming convention for enums is E with no underscore here, and then the name of what they're representing. You could call this something like E movement states, E player states, whatever you wanted. I think this kind of gets the idea across. And like I said, we basically want to come in here and we're going to create a new enumeration state. So you can see it's quite a broad, empty class that we have here. We can press the new button a few times and get a few different enumerators. They're just going to automatically name themselves. These are just kind of a named representation, and we're quite simply going to create one for each of the different states. So I'm going to rename these to idle, run, jump, and fall. Okay, so you'll notice that these are not associated with anything. They're not providing a certain flipbook. We're not assigning anything to these. These are purely a representation to allow us to easily update the current state and conveniently track them as we go through our logic. We can give them descriptions if we wanted to, but that's not needed. And something that's usually a good kind of practice to do as well is providing a kind of null or default state. So I'm going to add one more state and name this one default. Generally, if we ever hit this state, that means something's gone wrong. So this can be like a check that something has not been updated correctly. For some reason, this would be if, for instance, all of our movement checks have failed and we haven't returned that we're in any state at all. So that would mean we're like somewhere between idle, run, jump, and fall, which is something we've not accounted for. So we're going to set this to default, and I'm just going to click this arrow to move this up, because generally this will be the first enum state that we provide. So with that done, we can close this. We now have our new variable, and that's what we're going to use this as, is a variable type in our player class. So if we come down to the variables option, we'll click this, we'll name this movement state. And for the variable type, we want to use the drop down, find our E movement or E player movement. So the thing that we've just created and named ourselves. And we can see now that if we drag this in, we get our variable pin. And if we do something like use our select node that we've seen a few times now, we can see that we can select things between default, idle, run, jump, and fall. We could also set this as a variable. So again, ideally what you want to do, we're going to come in, alt drag this next to the event begin play, move this around a little bit, and we're just going to ensure that when the game starts, we're going to set this to the default state. It's kind of set to default anyway, but again, if we're ever testing anything, say we wanted to just test the jump, then we might forget to reset this at some point, so it's good to set this to a default to begin with. Then when we're updating our flipbook, we will keep track of this and be updating this based on what the player is doing. So back inside of the flipbook update, I'm going to get rid of this for now. We can move this aside. We're going to reuse some of this as we go through, but most of this will be gutted and removed in just a moment. From the update flipbook, we can set the movement state again. And again, if you're not familiar with this, if we just set a variable here, it's going to create the execution pins between both of these. And we basically want this to be the return of a set of checks. So we're going to be very familiar by the end of this with our select node, as this can provide some really useful, easy to read, automated code in different ways. So what we want to do is we're going to set this to be the return of a set of logic using our select node. Now the first thing we can check, again we've got most of this ready to go. We can start by checking if the player's on the ground. So this is our grounded logic. So I'm just going to Control X and Control V that down here. So we won't need this again, so we can just reuse it here. So what this is now saying is if we're on the ground, if this is false, of course, that means we are idle. So we're going to set this to idle here on false. So we're going to assume that we're not moving. That does leave us with some more logic that we need here. So this is going to be this true variable will be based on the return of the next select node that we use. So we'll use another select node here. We can see it's passing through the movement state to all of these. So these pins are all expecting the E movement state. And what we want to do now is check whether or not we're falling. So if this hasn't been the case, which means we're going to fall through and check the next select node, we now want to know whether or not we're falling. So again, we can Control X and Control V so that we know that we're reusing and accounting for all of the movement states we've already looked into over here. So again, if this is true, we are falling. We already know that we want to know in which direction we're falling. So we can't set this to jump or fall because this could be two options. So that lets us know this is another select option here, or another scenario where the select node is going to work. And that's going to be the return of this check here. So remember that was our positive or negative check for the vertical movement. So again, Control X, Control V. So we now have all of our checks. So we know that if this returns, we won't need any selects here. This means that if this returns true, then we are falling because we're going in a negative value just here. So we'll say fall for true and jump for false. So that accounts for our jumping movement, the different options that can come from that. That leaves us with just one option here. So for this select, we know that this is not moving. So we've got idle. That means this would be moving, but on the ground, which means this is going to be our running logic. So we're going to go into the movement state of run. And then this is our falling logic. So we're going to be in the movement state of either jump or fall. So we can leave some comments here just so that we can easily come back to this a bit later. So we're going to say that this one is checking for the air movement. Specifically, I guess that would be the velocity in which we're moving. Failing that, we know that we're not in the air. So we're going to check for the ground movement. So we'll leave a comment here for that. And this one, if we're not moving in the air or the ground, then we're going to return idle. So some nice comments to come back to just to kind of remind us what these are doing. And the best way to think about these, if this is again completely new to you, is these are kind of falling through. So as this is being updated, the first thing this is going to do is going to select what movement type to set this to. So if the velocity isn't equal to 0, then we're not just going to return false here. We're going to go and check the next select node because that would mean it's true. And then we're going to check this logic. And then again, if that isn't the case, so if that's true, then we're going to go back and see what our final check scenario could be. And that's going to give us some type of air movement. So this will actually already be working if we had the final stage, which is going to be setting our flipbook. And hopefully this is going to be the bit which kind of solidifies why this can be so useful. So we can now unhook all of this, select just one of these set flipbook nodes here. So Control X, Control V. Ideally I would have brought the sprite with that as well. So we'll hook this sprite up into this. We'll plug this in here. And we're going to use that useful select node one more time. So what we're going to do is we're going to select the flipbook that we want to display based on our enum that we have tracked. So we'll pull from here again and type select. Quite simply, this is going to be really, again, quite interesting, I think, for those of you who might not have seen this before, but we can control drag in the movement state into the index. So we're going to get the state, and we'll see that that will automatically read how many different states this has and provide a select node for each of those states. So that means that we can now set this flipbook just once based on what's being returned here. This is going to be a good tell sign again, so we're going to leave default empty, purposely leaving this empty. So again, if we ever see that our sprite isn't playing anything, then we know that something's gone wrong and we haven't updated a state. Otherwise, we can take all of these values that we've stored over here. We're going to plug the idle into idle, the jump into jump, run into run, and fall into fall. Pretty much as you would expect, and then just make sure we can see them all. And that is really our state machine kind of set up and ready to go here to check for what to do with the player animation. It means we don't need all of this branching logic. We can get rid of all of these now. We'll be calling the set flipbook function just once and passing in the result of whatever happens to our movement state and how that's tracked. So we can also see this in work a little bit here. I'm going to add one sequence down here, and you'll see that this is updating constantly. So we can do a print string, just so we can kind of visualize as well how this is operating. We can convert the enum state to a string, and this will, when we play this, keep track of this for us. So we're not pressing anything, which means we're in the idle state. If I jump, then we're jumping and then falling, jumping, falling, and running. So all of this is being tracked based exactly on how that movement state is being updated, and based on pretty much the same checks that we had previously, but rather than having branching checks going everywhere, we've now just got this one kind of logical flow of fall through states based on what's being selected and the calculation being passed in to that select node. Then all of this is being finalized by setting the flipbook based on the current movement state. So again, very easy to read, very easy to manage. And this also means that if we ever wanted to add something else, if we added things like a double jump or a wall slide, all we need to do, we don't need to add extra branch statements. Usually you would need to interrupt another check somewhere else, and it would really break the kind of flow of the logic that we had going over here. All we need to do is return to our movement state here. We'd add two new things. I would say wall slide and double jump. That would immediately add two new flipbooks just here. And then we could just run some other logic off of here. So again, if we're in the air and we're also wall sliding, then we'd have another select node to check for that and would return either jump, fall, or wall slide. Or if we're jumping and it's the second time we've pressed it, we'd return another select node here that we've just momentarily entered double jump, change that movement state, and again, this would all be updated pretty much automatically for us. There is no real like automated system for this, but I think this is kind of getting to that state where it's as kind of reusable and flexible as we can make it for this kind of project. So just before wrapping this up, make sure that we go back. We don't want this to sprint constantly. If you ever add another sequence, another execution pin from the sequence, we can right click on this and remove execution pin. So we're now just doing the flipbook and the rotation update. And as always, make sure that we compile and save this. We won't need the player movement to be open any longer. And I think that puts us in a pretty good state where the player's pretty much fleshed out. We have them doing everything that we want in the most robust way that I can think of doing it for a small project like this. I think what we can do now is we can move on to the interaction with other things. For the health pickups and things to have any use, or the enemies to really provide any kind of danger or hazard to us, we're going to need to start implementing a health feature. So with the movement pretty much fully implemented at this stage, I think it's a good time to start looking at how we can interact with other things in the game that we have planned. So the enemies, the pickups, they all kind of need us to have this concept of health and damage. So we can start by adding a health system to our player, which is what we'll be doing now. And then we'll look into how we can visualize this and get that to update based on what is being interacted with in the world. So to begin with, the health is a very simple concept. We're going to track this in floats just because I know that will be easier for us to implement that with the widget system a bit later. We could represent this as an integer value, especially if you had a health system where it's just like hearts or something, you'd be taking one heart away at a time. That would be perfect as an int. But for now, I'm going to create two new variables of type float, one named default health and one named health. Next, we can compile this so that we have access to these two new variables. And what we want to do is I'm going to set default health to a nice round value of 100. So we'll start with 100 health, and the health itself we'll leave to 0 to begin with. Now on the construction script, you could do this on the event begin play as well, but generally things like this, people like to put in the construction script so that we know even before we begin playing, we're going to reset our current health to the maximum health that we can have, or the default health. So we're going to get the default health by control dragging and set the health by alt dragging, and we'll quite simply set health to be default health. So now we know that, again, we can do some tests if we want to unhook this, but in the main game, in the full game, if we're ever playing around with things here and we wanted to quickly test something between the widgets and set the health to a different value, we know that when we start playing, or when this is updated in the constructor, that we will be setting our main health value back to the maximum we want that to have. To demonstrate this, again, if we just press on the begin play, we'll start debugging a lot, I think, with print strings, just to make sure that things are making sense as we go through. So we can now just say that our health will be printed to the screen, and we're starting with the 100 health. So that's nice and simple. That is our update to having health. We now have that concept. Of course, we next want to have the concept of damage. So damage is very simple, and in fact we'll be using an event that comes pre-built with any actor class in the game, and that is a function named AnyDamage. So we've got the event AnyDamage. We can see that the target is an actor, and the great thing about this is we can kind of bypass a little bit of casting and knowing exactly what we are communicating with when it comes to damage systems. We can literally just say, if something has a function on it which is expecting to have damage handled, call the AnyDamage function, pass in some information, usually the damage amount, and let that class work out and handle that logic that it's meant to be controlling. It's a very kind of object-oriented approach to programming. It decouples a lot of references, can keep your projects tidier and easier to maintain, and also saves, in some cases, on performance as well. So what we're going to be doing, whenever a damage amount is passed in, we're going to set the current health to a new value. So we're going to be setting this, and we want this to be the current health. So we're going to get the current health minus a float, which will be the damage being passed in. So if we've got 100 health and 20 is passed in, we're going to pass that into our health value here, and we would have 80 health. Now, again, we can do some debugging here. It's always nice to debug things as we go through. So I'm going to create a temporary input. Generally, I wouldn't create inputs in the event graph or even outside of the project settings, but because this is going to be temporary, I'll just remember to remove this later. And let's say we're going to press H. So we're going to find the key binding for H. H for health, and whenever we press this, we're going to call the apply any damage or apply damage. And the reason this is called any damage, if you're not familiar, is we do have different types. So we could bind this to the event point damage, radial damage, but if we use any damage, it means regardless of the type of damage being passed to us, this will be fired off and take health away. So we're just going to call the default apply damage function. The actor that we want to damage is a bit strange, but this is going to be ourself. So remember, this is just a debug function here so that we can check our health system is working. And the damage that we want to pass in, let's say that 20 units of damage that I mentioned a moment ago. And if we wanted to check different things like who the damage was caused by or instigated by as well, these would be for things like if you had different offsets for types of damage, so ballistic damage versus explosive damage and things like that. You could find out what the initial instigator was and whether you should apply the full amount of damage or like a modified version based on that. But again, we're just going to be going for a very simple type of damage here, 20 flat units of damage. And what we want to do is whenever this is called, we're going to do another print string, and we will print the value of our current health. Now this is going to have a few issues, and we're going to fix that in a moment, and you'll see what those are as we're debugging. So we can press H, and we can see that the damage is being called. We've got that down to 0, so the player should now be dead. If we press H again a few more times, we're going into minus values. So what we want to do to stop any weirdness like that happening where we could potentially kill the player after they've already been killed, we're going to clamp this to a certain value. So we'll pull from here, we'll clamp this to a float. We'll make sure that the minimum is 0, so we can now never go past that 0 threshold. And the maximum I'm going to set to be default health. So if we ever use this in a way where a very common thing you'll see is that health systems can basically be passing in negative damage. So you could pass in minus 20 damage. Obviously a minus minus a minus would be a positive, so you start adding on that way health to your player. We probably won't get into anything that confusing in this playlist. We're just going to add a very simple add health function. There are issues that come with trying to use the damage system as a healing system as well. Some of the logic, especially if you start adding modifiers and trying to change things up, that can get a little bit confusing. But to account for that, we could make sure that we don't ever allow anything to pass a value to set us, essentially cheating, I suppose, past our maximum default health value. And the final step, we want to add in the concept again of actually dying. So when we do get to this 0 health value, we're going to check a few things for whether the player's died and create a new function ready for that. So we'll create a new Boolean value here, and I'll call this one B is dead. So it can be useful to track the state of the player. It seems a bit obvious, but we want to again avoid things like if the player is killed and then picks up health, do we allow them to revive, and if so, and they're damaged again, can they die a second time? So to avoid anything weird like that, we'll make sure that this defaults to obviously false. We don't want them to start dead, but then if we get to a certain value, then we're going to want to set this to be true. So what we're doing is we'll do a branch check here, and we're going to say if the current health, rather than pulling from this pin, you could if you wanted to. I quite like having the extra variable here. We can control drag this in. It's no more expensive or anything. And then we can do a comparison. So if this is less than or equal to, and again, some people find this a bit weird. Program this as you want. You can say less than if you want or equal to if you wanted to. Because we have this clamping value here, we should never get below 0. But again, this can change at any point. Another programmer might come in, find that they don't want this to be clamped. But of course, you still probably want anything less than 0 to be dead. So accounting for things like that, I'm just going to say less than or equal to 0 for the health is going to be classed as dead. So that isn't a programming oversight. It's just something I like to do because you never know how the project's going to go in the future. Like I said, you could work with someone else. They could come in and decide this clamp is irrelevant, not useful, or they want to use the clamp in a different way, in which case you could start going into negative numbers and still not have your player die. So if that's true, then we're going to say that this is a now dead player. And again, just for this added security, probably not something we need in such a simple project, but I'm going to say that we can only do this if the health is less than or equal to 0, and we'll throw in an AND Boolean check, and we're not already dead. So we're going to say is dead isn't equal to true. And an easier way to say that, sorry, is to just say is not true, so not Boolean. So if we're not dead already, and the health is less than or equal to 0. So again, this is the kind of checks that you want to throw in just to make sure that you can have weird things. I've seen it in some games where they haven't done these types of checks. The way that I'm planning on doing this, I think we'll have like a Mario or Sonic death animation. So when you die, you'll be launched into the air. You'll have the input removed from the player and you'll kind of animate out of the screen. And what I've seen in some games, because they haven't done a simple check like this, another projectile will hit them. I'm guessing that they also didn't do a less than or equal to check or a clamping check. And what happens is that death animation keeps playing and they essentially keep re-entering the death loop until they stop getting hit by something, even though they've technically already died that once. So it may seem a bit overkill, but these are just kind of nice, simple checks, and they add that safety that you're not going to have a buggy looking game where you can die multiple times in a single life. And that's the worst thing as well, especially if you have a life-based game, then that could start taking away multiple lives, even though you haven't even respawned at that stage. So if that's false, we don't need to do anything at all. Of course, if that's false, we're just still going to be running around the level, doing fine. You could, if you wanted, this might be where if that is false, you've taken some damage, you might want to play a knockback effect or a flashing animation, enter into some kind of invincibility time. That kind of thing can be done here. What we do want to consider though, if that's true, we're going to play a new function. So we'll add a new function here and we'll just call this one player died. Now at the moment, we don't have anything to really place in here. So I'm going to add another print string. This will be its own topic a little bit later. But again, just so that we can test this is going to be working, we'll do the player died function call off of this and we'll just play that print string. So coming in again, we can press H until the health has gone all the way down, and we can see now the player has died, and that's been tracked correctly. So we know that all of this is working as we wanted, and the important thing again, to make sure that those checks have been worthwhile, we can keep pressing H, and we're not getting multiple player died function calls, so we know that that's nice and safe. We're not able to keep entering some kind of infinite death loop. So that's pretty much as complex as our health system needs to be. We can come back and make some improvements later. I think the next thing is going to be adding some kind of visualization to that health system through the use of widgets. So this is probably all we need to do in here for now. We can close the player class out again, make sure you compile and save. At some point I seem to have had a leftover tile map just here, so I'm just going to delete the old one and make sure that we have the correct one here. That's perfect. And that means that we're now good to go ahead and create our widget for the player health. To get started with this process, we're just going to create a new folder, which I will call UI. I'll be placing this in the base blueprints folder, and then inside of here, we'll just be creating a brand new widget class. To find these, we're going to right click, we'll go to the user interface option, so not under blueprints this time, and we're going to go to the widget blueprint option here. The naming convention for these classes will be WBP underscore, so widget blueprint underscore, and then the name of the class. I'm just going to call this one player health. Inside of the class, if you're not familiar, we're going to take a very kind of brief overview here. But what we have in the middle here is a canvas. So this is kind of like the workspace in which we can add our different elements to make up the interface. In this case, that's just going to be a health bar, but this could also make up things like menus. We could add in buttons, text, and many other things to this canvas here. And we can see that's represented to the left-hand side. We have our canvas. And if we were to drag things onto the canvas, we'll see that does appear within this screen space just here. To drive the health bar though, what we're going to need is a progress bar. So this is pretty much set up perfectly. We have control over filling this, so we can fill this with a value, which in this case is going to represent our health. I'm just going to drag this out to make this a little bit longer, and I think that should be a pretty decent size. Now the way that this works is we have this percentage value just down here on the right hand side when we have this selected, and basically as we drag this up and down we have control over how full this is. Now we can see this is a normalized value between 0 and 1, so we'll need to do a quick calculation a bit later to take into account our health value and get this to display between a value of 0 and 1 based on how much health the player has left. Now another thing is, if you've seen any of my other content or tutorials, you may be familiar with my disdain to this gradient default kind of Unreal texture here. So the most important and first thing we're going to do is we're going to drop down to the appearance. We'll go to the style option over here, and we want to change the background image and the fill image, so we don't get this weird gradient thing going on at the top here. It also means as well, this is a nice way to jump in and find out how to update and change the style of your health bar if you had something custom that you wanted to bring into the engine to use here. So I don't have anything made for this. What I'm generally do with these, just to make them look a little bit more kind of modern and go for that minimal approach, is we're going to drop down the background first of all. Ideally we'd have a texture that we've brought in, especially for something like this. A nice kind of pixel texture would be pretty good. As we don't have that, and of course using the images that we have isn't really going to work here, what I'm going to do instead is go to these view options down here. I'm going to toggle on to show the engine content. I'm just going to search for a white square. And we can see here we have the white square texture, and that's going to be perfectly fine. It doesn't really matter how big it is because that's all scaled based on these options just here. But we can see we've now just got a plain white texture in the background. That still leaves this weird sort of gradient thing for the fill. So again, in the style, I'm just going to copy this. We can right click, copy this, and then paste this into the fill image here. And we can see that's been replaced as well. Now in this case, for whatever reason, that hasn't actually worked properly. So if that does happen, then we can just select one of the others and maybe select back, just so we're using the same texture on both. So we have to pull less in from the engine content that way. So we're going to use the same white square texture in both slots. So we can now see that does look immediately a lot better than it did, and still works in exactly the same way because that scaling is happening automated based on the images being passed in. So we still get the full option to change this percentage bar, and that will either fill or completely deplete our health bar. Now once you've taken this step, the next thing we want to do is make sure that we go back down to the view options and then untick the show engine content. Otherwise we're going to get a lot more information in this search bar than we want. Generally I think things like health have a fairly uniform color, which I think most people would agree is green. So I'm going to change this from blue and change this to some kind of green to yellow tint here. And again, I think that's going to be pretty good for our health system. Now another thing you can change if you've never used the progress bar before, you can also change, so this is going to update the color of the health as we change that percentage slider. If you wanted to also change the background color, we can give our style color as well. So we're going to change the tint of the background and we can make this something darker or lighter or something completely different depending on how you wanted this to look. So I'm just going to go for a nice simple grey background, slide this to a slightly darker grey just here, maybe not full black, but a dark grey with a nice bright green health bar should look pretty good. So for the percentage, we can leave that because we'll be doing all of this in code, but this gives us a nice way to visualize what's happening before we get the code going. Now what I want to do at the moment, of course, if we just go ahead with this, we don't have this being called, we will not be seeing this in game. So before we add any logic in here, let's go ahead back over to our player class And inside of the player class, we can start creating our health widget and making sure that we display this. So it's quite simple. If you haven't worked with widgets before, what we want to do is on the begin play, we want to create a widget. So we're just going to call the create widget function. And from this, we want to pass in the widget to create, which is going to be our WBP underscore player health. And a lot of people may think this would be working now if you press play, just to double check that it's not. And this is because we've created the object, but we haven't done anything with it. So this does exist, but we just haven't told it to display or how to behave. So what we want to do is from the return value, now that we have this, we're going to promote this to a variable first of all, because we will be using this a little bit later. We're going to want to call various functions and update values on our widget system later. So it's going to be useful to have a reference to this. So we're going to call this one health widget ref. So we have a reference now to the health widget whenever we need to do anything with this again. And then from here, we'll be calling a widget specific function, which is add to viewport. So we've got the add to viewport option, and that quite simply takes this object and will tell the system to display it on the player's current screen. So that means now if we come in, we can see that we have our widget. Of course, something just happened a little bit strange there. We can see at the top left-hand side, we have our health widget showing as expected. Now, it seems somewhere along the line, the update Flipbook function has somewhat broken with the jump animation. So it seems as though I've just not got anything filled in the jump slot. Just in case you have that same issue, I'll keep this in the video. That should have been assigned earlier. I think that was working previously, but we'll just double check. So now we can jump, fall and run, and all of that's perfectly fine, just in case you were getting the same issue though. The main thing was the focus of the health bar here. So we now have the health bar displaying. Of course, we can take damage. We still have our function to call our damage, our kind of debug. So we can see that I've pressed H several times there, and we have it debugging that the player has died. But of course, that isn't syncing up with our health widget. So that's going to be the next step. So back in the widget class, we just need to add some functionality to register when a health value has been updated. Now I want to show you first of all the way that I still see a lot of people doing this in certain tutorials online, and it's a habit that I kind of want to help people get out of, and it's kind of bad practice, and I'll show you why as we go through. So we're going to do it the bad way first of all, just so that you know to avoid this and the ways around this if you see it in the future. Now what you might see is people will come down to the percentage value here, and we have a binding option, and we can bind this to a new function. So if we press that button, this is just taking us from the designer view here to the graph view. So the designer view is where we add all of our visualization, all of our elements, and flesh out that widget. And then the graph is kind of like our event graph essentially in any other blueprint. So this is where we put all of our logic. And basically adding that binding is just automatically creating a function for us and binding the return value of that function to our widget element. So in this case, it's a value, float value, because this is bound to the float percentage value. Now the reason that this is bad, what you'll find people do is they'll get the player pawn. So we use the default functionality, and let's say they'll just do something simple like casting to make sure that it's the player base. We know that inside of the player base we have our health value, so they can then get the health value. And then they'll plug that in and potentially plug this in. Now this isn't going to work because that calculation I mentioned, we need to normalize this value. But again, we're not going to keep this. This is pretty bad. This is just kind of an example of how not to do it, so you know what to avoid, and then we'll see why. So what this is doing now, we're binding this to the player class, we're casting, and then checking what the current health value is. So if we press play, we can see that is now updating, and I'm going to need to press this quite a lot, and then the health is going to go down to 0. So we now at least have that updating. But let's see why this isn't such a good idea. So what's actually happening here is this is working somewhat like a tick event. So if we throw a print string in here, and we'll just print hello, it doesn't matter what this is saying, and then press play, even when the health isn't being updated, even when we're just completely idle and not doing anything at all, we have our bound functionality here, just checking, constantly running, and in this case, not just constantly running, but constantly casting to another class, constantly refreshing this kind of memory location, and all of the variables that might be within this class are being passed to and from, just to double check that the health value hasn't changed. So that was really the entire kind of point of that side tangent here, is whenever you see people, if you're following other content and they recommend using a binding, kind of skip that bit. Really not very good practice. And what we want to do is we're going to unbind this. So we'll remove this binding, really just never use this button. I think it was a legacy kind of carryover for in-house testing, which just never got removed. Is really not meant to be part of the development pipeline. And whilst casting and event ticks are not completely sacrilege. They can be used in games perfectly fine. If you imagine that you had an entire widget, not just one health bar, but an entire widget, a mana bar, your player text, the icons and everything around a more fully fleshed out kind of widget. At that stage, you're not just doing this binding and casting once, you could be doing it 5, 10, 15 times per widget just to check that nothing's happened. So hopefully that kind of makes sense why we're not going to do that. So what we need to do to tidy this up, we're going to just completely delete this. We'll get rid of that percentage function. We can go back as well and we'll rename our health bar from progress bar to player health bar. Just because when we come back over to the graph section, that now shows the name in a more kind of logical way. We know exactly what we're looking at. So we do want another function though. What we're going to do is we're going to drop this down into a function. We're going to name this one update health. And this is a little bit more of a manual approach, so it does take a little bit longer to do it this way. But again, we're saving that performance and we're really kind of in full control then over when this gets called. So instead what we'll do is drag in the player health bar reference, the asset which is being used in the designer. We're going to pull from here, and I'm going to call the set percentage function node. So the percent, remember, is the thing that we can drag up and down, normalize between 0 and 1, and we just want to hook this up. So whenever this function is called, which should only be done when the health is actually changing, so when we're picking up a health bonus or when we're taking damage, we're then going to pass this pin into the health function, and we can call that across. Now again, remember, this is expecting a number between 0 and 1. And our health is currently between 0 and 100. So as we've seen previously, what this does is at the moment, if we keep calling this, it's only going to change when it's either over 1 or less than 1, which is in our case going to be when it hits 0. So we're not going to see the health bar moving up and down. Instead, what we want to do to normalize a value is quite simple. We're going to, the reason I've dragged this in is because we now have a float value called in%, and we're just going to change this one to be called health. And then quite simply, we want another value, which is the default or maximum health. So I'm going to add another value here and change this to a float and name this one max health. And basically, a normalized value is just going to be our current value divided by the maximum value. So we'll pull this from here and we're going to divide our health by our maximum health and plug in that normalized value. So that's always going to return now a value between 0 and 1. If that doesn't fully make sense, just throw a print string on the end of this and do some tests and see what happens when we go through and call this function in a moment. But basically, if we have a health of 50 and we divide that by 100, of course, we're going to get 0.5. So this is how we're getting that value from 0 to 1. We're never going to go past that range. Then the way that we use this, so this is actually the health function ready to go for us. And remember, we've got that reference on the player class. So we'll return here. And what we want to do is when we begin play, let's create a function that we're going to call on the begin play first of all, named update health. Okay, and inside of update health, we're going to get our widget reference. We're going to call that function here, which was again update health. And we just want to pass in what our current health is. And then remember, that's going to be divided by our maximum health, which in this case is our default health. Because remember, in the construction script, we're setting the health to be default health. And we're also in the health system, we're making sure that we never go past the maximum is never going to be more than default health. So this is why we've set it up this way. It's all kind of coming together now. And the reason that I'm doing this on begin play is remember the way that we can kind of play around with the widget here. So like I've said, it's really nice that we can come in, check the different stars. If we ever want to check the color of the background of our health bar, we can always play around with this percentage bar here. We can then come in, play with the different colors, add some different images, and we may forget to reset this to either full or minimum. So what we want to do in our player class is make sure we have full control over this. So on the begin play, once we've created the widget, we're also just going to call our update health function, and we'll let that do its thing. Now, the next thing is when we take damage, we can also do this down here. So in between our branch to check whether or not we've died. Again, whenever we have the health being updated, we're going to want to call that update health function. So we'll just pull from here, call the update health function here. And remember, if you're doing that between 2 execution pins, it will always fill that final execution pin for you. So now what should happen is, although we haven't updated or changed our widget here in the kind of visual element of this, we're going to call that function on begin play. That will find out that we have full health, so it should fill our health for us. And then if we play around with our debug health system, so the debug button that we have here, the apply damage, then we should see our widget being updated. So here we have full health, press H, and this is going down a small percent based on what I have here, so 20%, which is looking about right for that normalized value. If I make this 50 damage, so half of our health, then we're going to lose half of a bar, and then the next half we have died. So again, we can just double check that our maths is definitely doing the right thing. And let's say 99, we should have like the tiniest sliver of health. And we can see that we've got pretty much 1 health left. And again, one more time and we've died. So we know that this is working correctly. This is the main thing. This is why we add these handy kind of debug functions in, just to check when we're doing new systems that they are being implemented correctly. Before we even have enemies and things like that, we can easily test things with this. Now, what I'll do is this is a little bit hard to find. I'm just going to call this debug in a comment and I'll make this red. So we'll never forget that at some point we probably want to remove this. We don't want this to be shipped because, of course, we don't want the player to be playing around with the keyboard and then suddenly taking health off. So we'll come back and remember to remove this when we've completely finished with the health system. So back in the widgets, that is pretty much everything. So we'll just double check. We have all of this tidied up. We don't really need a comment here. We can see that's just normalizing a value, making sure that we don't have our binding. Hopefully, again, that makes sense why we don't bind anything to a widget function, whether that's a button, a set of text, a progress bar. Nothing really needs to be bound. It's nicer to have this full control, and you can see now that this function is only being called at the specific times that we think something might need to be updated on the player's health. So on the begin play, and at the moment in the damage system. That should be all we need to do in the widget class and the player for a little while. So what we'll do, in fact, we're going to use the player in just a moment for the enemy damage. So we can just close the widget class for now, make sure that we've compiled and saved all of our updates. So before jumping into the player health and damage system, when interacting with the enemies, trying to flesh that out before we even have anything to really test it against again, I think the best thing to do is actually take a break away from the player class at this stage, and we'll implement the basic enemy class to begin with, and then our bat class, and we can check that against the player when they interact with each other. So for the time being, we will in fact close the player class if you still have that open. And inside of the blueprints folder, I'll create another folder again as we're going to have a few classes nested in here. I'll call this one enemies. And although we'll only be creating one enemy in this set of videos, I did want to introduce the idea of inheritance and show how we can create a kind of hierarchy of different enemy types with a base class accounting for a lot of the more generic functionality and variables. So we will be taking that approach, and then you can easily extend this to your own other enemies such as mushroom characters or stationary kind of turret enemies or anything that you really wanted to add in. So for our base class, we're going to right click in here, we'll create a new blueprint class, and I'm actually going to reuse the paper 2D character class again. So if we find our paper character, the reason being is that if we ever did want to add detailed kind of AI implementations into this, then this will have everything ready to go in that character movement system, which will automatically be set up to account for navigation volumes and how to interact with them. Not only that, this will also have our Flipbooks and everything else like that we need to go for animating and setting things up, and including the gravity, the capsule colliders, and everything that we've been using. So for this one, this is going to be our base class. This will be the parent class that all other enemies inherit from. So we're going to call this one BP_enemy base. Now what we do inside of the base class, we try to keep the logic in here as generic as possible. So we account for everything that every child of this class might need to do. So that would be things like potentially movement, but maybe even that's a bit too specific because like I've already mentioned, one of the first two ideas that came to my mind were the enemy mushrooms, which would need some kind of movement quite likely. And then the second one was the turret enemy. So I've already come up with an idea of a character that I might want to put in that doesn't move at all. So that could be too specific, but they will all need things such as health values, a win, lose kind of death state when the player interacts with them, maybe a damage causing state and things like that. So that's slightly more generic that all child classes will probably need. Now the other good thing about using this paper character, we also have all of the other things that child classes will need as well. So we have our capsule collider. So again, we already have the collision properties of all child classes set up and ready to go. And we also have the sprite component. So again, all of our child classes are going to need to be visually represented somehow, probably with a paper 2D sprite because we're using a 2D platformer here. So again, this has a few of the components already in here that we're going to need in the future. Now, I'm not actually going to fill this. The reason being is that this is going to make sure that if we ever forget to provide a visual representation for our child or inherited classes, then by leaving this empty, that's going to be a very clear indicator that in the child class we've made a mistake and forgotten to do something. What we will need in here though is a couple of variables. So these are going to be our health trackers. This is going to be very similar to our player character class. So we'll have a float value. The first one I will name default health. And I'll copy this, so Control and W to copy this, and we'll just call this one health. And in the same way, we want this to always set the health at the start to be the default health. And let's set the default health. We'll give these a default of 100 as well. We can change this in the child classes, as you'll see a bit later, but we'll just assume that they all start with a flat 100 like the player does. The next thing we're going to want to do is add in a damage system. So again, all of our child classes, anything that inherits from this is likely going to need to take damage at some point. So we can go back into the event graph here. We can remove the functions that we're not going to need, which should be pretty much everything for now actually, and come in and add the on any damage. So that function that we've used before, the event any damage, we basically want to do the same calculation to take the health away from what's being passed in. And in fact, saying that, we can just jump back to our player, and inside of here, because if you've done the same thing as I have, named everything the same way, we can actually just pinch this. So we'll copy this from one class. It will realize that the names match up, and we can just pass this in here. So ideally at this stage, again, we're going for a very kind of basic minimum MVP, kind of minimum viable product for this project. But this is where you might want to start looking into things like components, reusable components like a health component, because we're already kind of copying logic between classes. So this means that this could be used as a kind of component or interface. So we don't need to keep redoing this. But for this, again, we just want to get things working. And this isn't necessarily bad coding practice, but we also don't want to take hundreds of videos just to get a simple platformer working. So this is going to update the enemy health whenever we take damage. And we already have the next part of the logic ready as well here. So we're not going to show any visual health representation. We can skip this bit, but we may as well go ahead and check the health again to make sure we are tracking whether or not we're dead. We can also copy this, and we'll make sure we don't copy the player died function, but we will be implementing something very similar in our enemy class. So we copy all of this, we'll come back over here, we'll paste this into the event graph. We're going to have one small issue, and that is that we haven't made this boolean yet, but if you ever get that, you can see we've got a slightly white line above this, which means this value doesn't exist. So if we press compile, we have an error. Nice and easy to fix this. We can right click somewhere near that white line, and we can tell it to create the variable is dead. So we now have that tracked in here as well at no extra cost to us. So we're now doing the same thing so that we don't have the ability like we didn't want with the player where we don't want to die more than once. We could have something where the player continuously jumps on an enemy and puts it in a constant kind of death loop, which could be quite funny now that I say that, but it could also look a little bit buggy and not quite be the mechanics or the results that you want. But we're doing the same check here. So if the health is less than or equal to 0, then we're dead. Again, I'm fully aware that we're clamping this, but just to future-proof our code, we're also going to make sure that nothing slips through this use case and we don't have an enemy at some point with minus 50 health which is still alive. And also if it's not dead, so we can't kill it multiple times, then we will kill our enemy, make sure that we set is dead to be true, and then we're going to make that function again, and we'll call this one enemy died. This one is going to be a little bit different. I'm not going to put any logic in here whatsoever. What I will do, I'll just add a reroute node just so we've got something visual and a comment around the reroute node. Okay, so a nice simple comment just to kind of tell us what this function is doing. So we've made this function, which is going to be left completely empty in the parent class, and it's expected to be used and completely overridden just in the child classes. Now we could do something here like calling the destroy function, but in the child classes we may want to do something such as I've put in the comment here, playing animations, particles, sound, and things like that. So we don't want to destroy the class before that's happened. Now we can change the way that functions are called. So we could call our child function first and then inherit the parent function afterwards and destroy it. But again, there may be some use cases where we don't even want it to be destroyed. Maybe we're going to have corpses kind of littered around the arena. Maybe that's going to be part of a mechanic where they need to keep existing. So to avoid any issues like that, I generally don't call destroy functions in the parent function calls at all or in the parent classes, but I will set up the function ready for that to be called so that the health is tracked and we know that the enemy has died. It saves us implementing the same functionality over and over in all of our child classes, but we get that freedom and flexibility to add in to the functions the unique logic and functionality based on the class which is calling that function. So what we're going to do, we will call this, we still want this to be called, even though nothing is happening, because in any child of this class now, when the health is being tracked and it's being classed as a dead enemy, then this is still going to be called. And we'll be seeing shortly how this can still be utilized in the child classes if you're not familiar with that. But that is pretty much it. So that is our base enemy class ready to go. That's for this project at least, the variables and functionality that I think are going to be the most generic, the things that any class that I could envision adding would need. And they're definitely the only things that our bat class is going to need to avoid us manually implementing this in that class as well. So to take that next look into the inheritance system, how we can get different classes to inherit functionality and variables and properties from their parent classes, we can now start creating our enemy bat. We can do that by going back to our enemies folder, and in here, from the enemy base, we're going to right click on this, and we get an option here to create a child blueprint class. So this class now inherits everything that we've just implemented in our base class. I'm just going to name this one BP_enemy_bat. And we can even see here, so if, again, you're not familiar with the Unreal class inheritance structure, we can see that the parent class is the enemy base. We can navigate to this, which will be just here, and we can see that the enemy base parent class is the paper character, which is the one we chose originally. If we click on this, this will take us to a C++ class, which will define all of these things here. So we're basically just inheriting the capsule component, the sprite component, and everything like that from our C++ parent class in this case. So I'll just get rid of the player class, we won't need that again. Inside of the enemy bat, what we want to do, we can start adding some of the visuals here. So we can add our sprite in this one. So remember, we're going to get all of this from our parent version. This has been left empty on purpose, so we can fill this in now with the animated bat. We'll also want to change the capsule component size, so we can just make this more of a perfect circle. So 34 and 34 seems about fine. It means we're not going to get that hit from the wingspan, but I think that's going to be acceptable. It's not going to look too odd in this type of game. And then just to check a few things here, so again, just in case you're not familiar, inside of the construction script, first of all, we can see that we have a call to our normal construction script, which is then calling the parent construction script. So what this is doing, if we double click into this, that will take us to the parent class, and we can see that basically the order of execution is we're going to call our own function first. So what we could do is add something like a print string here, which means that we would, in the construction script, print whatever's going to be on the print string, and then we would call our parent version, which is going to just set the health here. If we were to do this a different way, so in fact I'll show this just to get this point across. So we'll say print string, we'll say this is from child, and then in the base class we'll do a print string here as well. And I've just realized this is going to be a bit confusing because of the way it scrolls down the screen, but hopefully this should make sense. We'll say parent. So this is going to make it clear where these calls are coming from, and I'll change this one to be orange just so it's a little bit more obvious. And we can see there already, we've got a lot of different things. The construction scripts run pretty much constantly whenever you're changing something, compiling something in the editor. So if we bring in just the parent, we're just getting that parent function call. And I'm moving this because, again, the construction script is called whenever we move something in the editor. So what that's doing is it's setting the health and then calling that print string. In comparison, if we bring in the bat, we can see this is calling the child. It scrolls down, so we can see if I leave it for a while, the first one should be blue, child, parent, child. So it's calling the child function first, then the parent, and kind of looping that every time I move it a certain number of units. So this is the order here. Now we can change this, so if I hook this up first, and then hook this way, this will now fall into the parent's construction script first. It should now read parent and then child, because we're going to call our construction script on the parent first and call this print string. And then we're going to call our print string in the class that we're actually calling it from directly. So again, I'll just bring the enemy bat in, and it's a little bit hard to see again because I think that's overfilled the page, but we're now doing it in the other order. So we've got parent, then child, then parent, then child. So we can see it's going in the right order there. So hopefully that kind of makes sense how we have the structure of the order in which things are called when you're inheriting things from other classes, because we will be making use of this as we go through with the bat class. And that's exactly what I meant with we could override things in the enemy died event. We could have done something like placing the destroy function here and just making sure that when we override this function, we do the child's version first, which will be playing the effects, and then calling the parent function, which would handle the destruction of the class. But like I've mentioned, even with that kind of override, there may be situations where we don't want everything to be destroyed immediately. Having things like that kind of permanence in a game can be quite nice with the bodies and having different interactables when the enemies died. So for that reason, again, I'm just going to skip doing that and make sure that we do all of the functionality that we want inside of the child class. So the way this is going to work, we can get that one function out of the way to begin with, so we can actually look into overriding another function, which will be our enemy died override. So here in the functions, rather than recreating that, we can see that we have a few things that have already been defined in the enemy base. So we can override the any damage function in the enemy base, and we can override the enemy died function from the enemy base. We also have a bunch of functions we can override from the actor class, all of these again already being done in the general actor class setup, but the one we're interested in is the enemy died. So like I've said, we're going to keep this call to the parent just in case we ever do add anything generic that we want to happen in the base class. In this simple example, that's not going to happen, but just in case we did, then we'll keep that here. And you've already kind of seen how that works with the construction script, how this will be called first. That's essentially going to come in, do nothing, hit that reboot node, and then we'll call our own logic here. Now, against everything that I've just been saying, what we're going to do inside of the enemy back class is destroy the class. So in this case, we're not going to go into effects. There's plenty of tutorials on particle effects and sound effects and things like that. I'm just going to visualize the character being removed. So we'll be calling the destroy actor function whenever the player jumps on top of the enemy bat. Again, if you wanted to do something like adding an animation first, then you could add that here, have it go off screen, and then after a second or two, destroy it that way. But again, this is going to be a nice visual representation. We'll see that we jump on the bat and then it will disappear. So what this looks like at the moment, if we come in, we can bring the bat into the world. If we try and drag it somewhere on the tile map here, we can see it just rests just above it, but close enough. We want to set this to 0 on the y-axis. And to avoid that Z fighting, we're just going to make sure it doesn't go into the ground, and we can leave it somewhere like that. So if we come in and press play now, we have a bit of a streaming issue here. That will take a second, and then that should fix itself. And we can already see there's going to be a couple of issues I was expecting here, and that is that we can jump on this and we're going to be moved around and potentially be pushed backwards, which is what I was hoping would happen there. So because we've got two sphere colliders interacting with each other, it basically doesn't know which way to resolve the collision, and we can have that issue where we're moved forward and backwards on the y-axis. So whilst we have that kind of issue in mind, I'm just going to go back into the player class and we can solve this now. So in the player class, on the character movement, we've got the option here. If we search for constrain or just start typing constrain, we have the constrain to plane option. We basically want this to have a positive value on the y-axis, which means we're not going to allow it to move any direction on the y-axis. We still obviously want movement in the x and the z, which is left to right and up and down. But what this should do now is if we come back in and jump on the bat again, we can see that we're just pushed only left and right. So it's going to take in our velocity, and we should be able to do this as many times as we want without worrying about being pushed forward or backward. So that's the first issue. Now the next thing you may have noticed is the bat starting slightly higher up, but is always ending up on the floor. So of course we want our bat to be able to fly, and again we can easily do that inside of the enemy bat class this time. Going back to the character movement, and we've got a bunch of different kind of movement modes we can set. So we want the default land movement, strangely enough, to be flying. So basically when this is initialized, it will set the default movement type to land, and when we're kind of defaulting this to land, we want this to be classed as a flying movement. So it's kind of contradicting itself there, but just be aware, the main thing is that this is the default movement mode, which is land, and we want that to be flying. Then the way that that will work is if we come in and simulate this, we can see that that takes gravity away, and this is now classed as a flying character. So it can move side to side, we can move it up and down, and it's going to completely ignore gravity unless we override it to have some kind of bobbing animation with some gravity accounted for. But otherwise this is going to stay completely in the air. Even if we possess it, then we can come up and start jumping on the bat. So at this point we have a fairly stationary bat. The next thing we're going to want to do is add some kind of movement logic to this. I'm just going to make this very simple. It's going to fly left to right. It will pick at random whether it wants to move in a certain direction, and then it's going to be one of those enemies that when it hits a wall or something, collides with it or is in its path, it will just change direction and fly the other way. The actual movement for this class should be fairly simple to implement because again we're using the character movement component here. That means, as with our player class, just to kind of recap what we were doing, we can really leverage some of the movement logic already available within the character movement, provide it a direction that it needs to move, and that will be pretty much the logic that we need to do there. So that was on the input movement, and we can see we've got the add movement input. So we're going to do something very, very similar. In fact, if you have the player class already open, we can copy this node. We're going to use exactly the same thing. We'll move back on over to the enemy bat class. And the only difference, of course, is that because we don't have an input to drive this from, we're going to paste this in next to the event tick. hook this back up, and then all we really need to do is work out how we're going to get this scale value. So at the moment we have the X world direction to move in. So again, we're moving left and right. We don't need any forward or backwards or vertical movement for our bat. So if we actually go and play this right now, this would be doing at least the very basic movement that we need. We can simulate that here. We can see a couple of things are probably a little bit off. The first one is that the bat is flying backwards. The second, I would say he's moving a little bit too fast. And the final issue is the main kind of point of this, that he's always going to be moving in that forward or right direction. So what we're going to do is work out these different steps as we go through this class. So the first thing is going to be the easiest thing to approach, which will be changing the speed of the movement. We've seen again in the past that this is on the character movement component. So with this selected, do remember that we're using the default movement to be flying, which means we won't be changing the walk speed like we did with the player. Instead, we'll need to go down to the flying section and lower this. So I'm going to make this around about half at the speed that the player's moving. I think the player's defaulting to 600. So we'll make the maximum flying speed 300. This just means that it should be a little bit easier for the player or ourselves to kind of catch up and play around with the enemies. For testing and also for games, you normally want the player to feel a little bit more controllable and powerful than the enemies. So we can see that's fixed the movement speed, which is the first and kind of simple step to do here. So for the movement direction, what we can do is we can pull from here, and we'll use another of those select nodes that we've been getting used to. Again, I'm going to go for the utility select because I like the way that this will print out the true or false when we turn this to a Boolean. From here, I'm just going to drag and create or promote this to a variable, and I'll name this one bMoveRight. So again, we're defaulting to the positive naming of this, that move right will be the kind of expected default. And what we can do is we're going to set this. So if this is true, we're going to set this to be 1. And if this is false, we'll set this to be -1. So very similar to what we're doing with the input axis. 1 is going to be positive, moving right. -1 will be negative, moving left. Very similar logic, just a different way to drive this from a Boolean. Now to test this, we can very simply tick the I. So we'll make this public, hit compile. And we'll see that this will default to be false because the index here was false. And this means that if we grab our bat in the editor, we should have full control over the movement direction here by finding that Boolean. We've got the move right Boolean here, so we would expect if we leave this unticked, we'll now move left. Okay, so first test done. And if we tick this, we should be moving right. And we can see we now have control over the bat as expected. So that's going to be the kind of next part of the movement direction controlled. So we now have a variable to control this for us. Now a nice simple way that we can update this on the begin play so we can kind of randomize the way that the bat will be moving. I'm just going to remove the actor overlap. We won't be needing that. What we can do is we can alt drag in our variable, hook this up, and we can just pull from here and use a random Boolean function. So quite simply, this will have a 50-50 chance of picking true or false when we begin play. We won't have any control over this. We'll just use this completely random assignment of the Boolean value. And then when it gets to the event tick, that will be taken into account and our bat will be moving in different directions. Okay, so I've tried that there a few times and you can actually see somehow we did get an exactly 50-50 split of the randomization there. I wasn't expecting that, so take that for what it is. And what we can do here is make sure we won't need to be testing this anymore, so we can make this private again. Obviously, we just don't want too much to be exposed if it doesn't need to be. And the final thing for the kind of basic movement implementation, I'd say, is to get it facing the correct way. So of course, we do want this to collide with the surface. At the moment, if we get this moving left, then what's going to happen is we'll collide with that wall and just fly indefinitely into that wall. So we will be fleshing this out a little bit later to get the bat to change direction as soon as it hits a wall like this. But for now, I think we can just get the character facing the correct way. So as soon as we do change a direction, we can take in this move right variable that we're tracking, and we can make it look either left or right, depending on the way that it's moving. So again, to do this, it's very simple. I think in this case, rather than trying to work out controller rotations and things like that, this is one of those things where you can do it either way. There's no real right or wrong way, especially for something like an enemy. I know that we're not going to have anything like a bat spitting fireballs or something, so we don't need to be concerned with the rotation direction or adding in subcomponents. So I wanted to show the other way that I've mentioned to do this, which is using the sprite scaling. So completely optional, but I'd quite like to show you as many different ways to do things as possible so that you have those options in your arsenal ready to go. So what we're going to do is, depending on the direction that we're moving, we're going to get our sprite component. You could also do this to the entire actor, completely up to you how you manage this. So you could set the scale of the actor, but quite simply, remember that what I said, one option that we could have done with our player character, rather than changing the rotation, is to simply get our X scale, set this to -1, and we're facing the other direction. So that's all we're going to do. A nice simple approach here. And like I said, just another option I wanted to show you. So to manage this, what we'll do is we'll first of all get the current scale, as we'll need this for a calculation in just a moment. And we can do this with the get world scale for the sprite here. We can split the structure pin. So we have the X, Y, and the Z. And then in a similar way, we're going to then set the scale based on this. So again, we can set the world scale 3D for our sprite. And again, we're going to want to split the structure pin, just because if you think about it, we don't want to be flipping the Y or the Z, so we can just automatically hook these up so that these never change. You could hard code them to 1. You may forget why you're doing that. The main thing is we want to work out the calculation based on our X value. Then the final thing is we're going to pull from here and we're going to multiply this by a float. So a float multiplied by a float. The return value will be what we want to set the scale of this to be. And as ever, we're going to pull from this final pin and we'll use a select node. Again, we're going to go for the utilities option. Just to recap, we don't want that A or B. That's a little bit ambiguous. And of course, as soon as we turn this to use the Boolean value, we get the true or false. So that again is very human readable. We now know that if we're moving right, if that is true, then we want this to be scaled in one way. If it's false, then we want it to be scaled the other. And as we've just seen, this is actually a little bit different because of the way that the assets are drawn. It's very kind of common that the player will be drawn facing right, the enemies are drawn facing left. It's just something I've noticed that 2D artists do, which means by default, moving right, we actually need to inverse this. So by default, as soon as the enemy starts moving right across the level, so if that's true, we actually want this to be a negative value, so we'll set this to -1. And if this is false, so if we're moving left, then we'll set this to +1. With that done, we can plug that in here, tidy this up a little bit, and that will be us good to go to test this out. Okay, and there we go. So the bat is now facing in the correct direction depending on which way that random boolean is selected at the begin play. If we're moving left, then he's flying forward to the left, and if we're moving right, it turns around and is moving forward to the right. To get the bat reacting to the walls as we kind of expect, there's going to be a few different kind of ground rules and expectations that I'm going to put into the logic, just so that we know that we have full control over how the bat could potentially interact with the different parts of the level, such as the floor, the player, different items, interactables, walls, and so on. So back inside of the enemy bat class, inside of the event graph, the first thing we want to do is the way that we're going to kind of handle this is going to be from the collision events. So as I've already mentioned, the basic outline of this is when the bat hits something, we want it to decide whether or not it should be turning around. So we already have the main component that we'll need for this, which of course is going to be the capsule component. On the capsule component, we can scroll down and we can find the on component hit event, and we can add this in. Now I'm just going to go through the way that I have this planned out. So you may want to have your enemy character interacting differently with the world. Generally though, there's a few kind of rules when it comes to the way that I kind of look at game design on a more concept and theory based premise than just the raw kind of mechanics behind it. So the first thing that always stands out to me the most is that one of the things that this enemy could potentially collide with will be the player class. And one thing I always find really weird when this happens is when the enemy hits the player and then has this automatic kind of logic triggered to make it turn around and move in the other direction. Especially when you break it down and think that the enemy is kind of really in the level just to either hunt down, find, or interact with the player class in some way to provide damage. Especially as I'm kind of approaching this like a very old school Sonic or Mario game, not some of the more recent ones where the enemies may pass through and have specific attack kind of montages where they throw or punch the character as an example. These are the ones which are going to purely provide contact damage. So I tend to think it feels a little bit strange if the one thing the enemy is intended to do is to walk into the player and cause damage and then turns around. So what I'm going to do is the first thing we will drive from this is we'll pull from the other actor pin to find out what we've hit. And we only want to do our collision check if that isn't equal to the player pawn. So we don't need to do any casting or anything here. We can literally check whether the one thing the only player in the game is going to be controlling, if the thing that we've hit isn't equal to that, so the other pawn or the player's pawn, we'll run a branch check from here. And if that's true, then we can go ahead and do our direction flipping logic. That's the first step done for this type of logic. The next thing is going to be finding, so if we have passed this one criteria that where we want to completely bail out and ignore any future logic, the next thing we can look at doing is checking the surface that we've hit or interactive against. And we can do that by dropping the hit pin just here. This provides a lot more information about the thing we've hit, such as the type of material it might have, its name, if it has a bone socket, the distance, and you can see all of the extra pins we've got here. Now, the one that we're going to be interested in is the normal, and this can give us an idea of the direction in which the hit was taken. So the next thing I wanted to account for is if something comes from above or below, so ceiling or a floor, or even another type of enemy or an interactive class, all of these things should also be ignored. So we can see how this looks if we drag from here, and we'll do a print string. And inside of the print string, we can just plug in the hit normal is going to be the one that we want here. So let's just have a quick compile of this one, and we can see what is going to be returned depending on where the bat is being hit. Okay, so if we're hitting a surface like this one straight on, we can see that we're getting a lot of hit returns from this single collision. Basically, for as long as this is colliding, kind of like a tick almost, we're going to be returning this hit function. Now, the important thing we can see here is that this is being hit on a positive 1 on the x-axis. So this isn't actually the hit position of the bat. Obviously, this is going to be -1 on the bat side left, as we're already aware of. What we're actually getting is the positive location of the thing that we're hitting, which is at 1 on the x-axis of this wall. So flipping this around, I'm just going to pause this as soon as we hit that little bit of a corner there. And in fact, what I'll do is go back in. We'll stop this because that's not going to be long enough, and we can increase this to something pretty high. So the first thing I want to show is the hit of this corner, because that's not quite straight on, but it's not below. We can see when we're getting these values like 0.25 and 0.9 or between 0.8, we can see that this gives us an idea. And also note, sorry, that's -0.2, because this is coming from the left-hand side of this little hill just here, but it's also kind of on the corner, which is the top of the hill. So we've got a positive on the Z, mostly positive on the Z, giving us an idea that this is a corner, and a clipping the side just here as well. So in this case, what I would do is I'm going to kind of take these values, and we can clamp certain ranges that we're going to ignore based on what's being returned. So if we let this go a little bit further, okay, so we can see a similar thing as we've hit this from, or we've been hit from above is the way that we want to look at this. We can see we're now getting a negative value on the Z because it's the bottom of the platform rather than the top of this hill. And again here on the X, we're getting a negative value because it's from the left-hand side of that platform. And we're going to expect pretty much the same sort of thing from that brick and the wall. And this is how we can use our hit normal to get some information about the direction in which we've been hit from. So the first thing we want to do is, rather than making our on-component hit node much bigger by splitting the structure pin, because remember, we're only actually interested in one of these, which is going to be the x-axis. So I'm just going to recombine this just to show you that if we keep doing this, it's going to get quite big. Another way around this is we can pull from here, and if you're not familiar, we can break this in a separate node. So they do the same thing. We can break this vector. It just means that we're going to have this in a slightly more separated location. We've already made this pretty long, so we can probably save a little bit of space by just separating this one out in a different node. Now from the X, I'm just going to be quite strict with this. So if this isn't equal to 0, so anything not 0 on the X-axis is going to be classed as a hit result that I want to respond to. So again, we're ignoring the Y and the Z, so floor and kind of foreground, background collisions potentially will be ignored. And anything which is higher or lower than 0, because you could see we're returning point values. So even if it's just like clipping a corner, then I'm going to class that as a reason to turn around. So as an example here, if we were to hit that corner again, even though it was like 0.2 or something, we would still flip around and change directions. Now you could add in ranges, so if it's between -0.4 or 0.4, then that could be the bottom of a hit result on the Z, and you may not want to respond to that type of thing. That's completely up to you if you wanted to add that level of complexity in. Hopefully it's kind of making sense how we can use this though. But just to get the bulk of the logic in, we're going to keep this nice and simple for now. So what we want to do now that we've got this condition checking, we're going to set our moving right direction. And just an old trick here is we're going to get the current moving right direction, and we'll set this to be whatever the current moving right condition is not. So we'll say move right equals to not move right, and we can use the not boolean check here, pass that in, and it's essentially just inverting it. So this is going to say if you're moving left, move right; if you're moving right, move left. Next, moving over, we're going to want to flip the direction of the bat, and we already have some logic above to do this. So of course we don't want to copy this code. Instead, what we're going to do is we can grab this like we've done before, right click on any of these nodes and collapse it to a function. For the name of this, we're not technically changing the rotation. Rather than calling it change rotation or update rotation or something, I'm going to name this one toggle facing direction. I just think that's the most accurate descriptor for what we're doing here. And then now we have this as a function, we can grab this in and we can plug this off of our function here. I already know that there's going to be some issues here because of the way that collisions are working. This here kind of gives you an idea of what might be happening because we get more than one of these function calls per collision essentially before we even have a chance to rotate. Because we're getting more of these returns per collision than we may want, we may get some clashing or flipping happening too quickly. So we can just check what's happening to begin. You can kind of see it there, it tried turning and then didn't quite, and then we've got some backward facing here. So it can look a little bit twitchy. So we want to make sure we have a little bit more control, especially on these kind of tight locations here, to make sure that we don't have too many updates happening at once. So to manage this, I'm going to use something called a do once node. As the name would indicate, this is going to only allow us to do something at that one time until we reset something. This is known as a flow control gate. So we're going to pass this in here. We're going to do this functionality just once after this, and I've put this in the wrong place. We want all of this to be after our do once, and so if this branch comes back as true, then we only want to toggle all of this once and change the direction once. Again, this is going to cause a problem because this will not automatically reset itself. So if we hit something now, this is going to be the longer way to check it, but we're going to hit this wall. And then if we hit this corner, we should hope to see this flip or do something. But because we have that do once in place, it means we're only going to keep moving forward now, and that functionality will never be checked again. So what we want to do next is once this has happened, we want to make a delay. We don't want this to reset immediately. Remember, part of the problem is that we're having too many hits colliding with the wall immediately until we kind of flip around. So we're going to add a delay node here. And the delay can be something very, very small. Something like 0.1 should be perfectly fine. And then when you see other people using this, a lot of the time they'll just throw in a reroute node over here, or pass in the wire here and throw in a reroute node. Try and make this a little bit more readable. I'll show you a way that we can get around this in just a moment. It's quite a simple thing to do, and just to keep the code more readable, but this will work. So we can now see that as we come in, we're going to hit this once, so we will have that called. And then we've got another problem that we can see here, so we're going to fix all of these as we go through. But the main thing is that we're now flipping around again, and that functionality is being called and checked more than once as long as we've had that 0.1 second delay, and we should see it happening again when we hit something here, and that is all working perfect. Well, apart from the fact the bat is flying backwards, that is all working perfect. Okay, so before finalizing and fixing that last problem, one thing again, we're looking quite a lot in this series of videos at a kind of cleaner way to code, hopefully. So whilst we have some nice things nested into functions, everything here is very kind of blocked out to do its own thing. And one of the things you hear quite a lot as a detractor from blueprints is how you get spaghetti code and it can be hard to read and maintain your code base. And that is true, it definitely can be if nothing is put into a function, if everything is placed in the event graph, if you have looping wires here, which are going to make it much harder to work out what's calling what when you start adding different things here and different branches and sequences coming off of this and everything's looping around back into the do once at some point, it's going to get very hard to work out which direction your logic is flowing. So instead, what we're going to do is we're going to remove this. That's not a great way to go ahead. We're going to create a custom event down here, so a nice simple fix. And we'll call this one reset direction change check. So throwing reset into the naming convention probably helps just here. We know that this is going to be calling some kind of built-in reset functionality quite a lot of the time in Unreal. In this case, it's going to be this flow gate and the do once node. Then of course from here, we're just going to pull from the delay, and we'll be calling that reset direction change check. So nothing too wild there. Most of you probably jumped to that as the first kind of fix for that kind of looping functionality. And now it just reads much, much more clearly. The best thing as well here is that as you're reading through this, if you're starting to add code later, you're kind of fleshing this out and expanding the logic, and this is getting a lot longer, going into different functions. The main thing now is we don't have to check where this random wire is going from one part of your blueprint to another. Double click on the node, and it will take you here and you can see what this is going to call. Trying to keep the code as clean, readable, and reusable as possible. So that's going to do the same thing. We know that there's still one bug to fix here, and I'll be honest, I'm not too sure why. What we have happening is the bat is still kind of flying backwards at some point, so it happened there. So I'm wondering if we throw in a print string here, making sure that we're only doing this once. It may still be somehow falling through this. Maybe this 0.1 isn't quite long enough, and it could be that we're toggling this multiple times. But maybe not toggling the direction or something. I'm not sure what's happening. So we'll print this, see what's happening. So we're only getting one hello returned there. It seemed to be happening a lot more on this corner. We're only getting one there as well. Okay, so that isn't happening, which means our do once is working correctly. So that is one good thing at least. And I'm going to keep this bit in as a kind of debugging tutorial. This wasn't intended, but sometimes, I mean, this is the way that programming goes. Development is usually not too straightforward. So this could be quite useful, hopefully, as a learning example. So the only other thing we're doing, we are flipping our Boolean check here. We're doing that once. We have our delay, which we know is working. So it means that it's going to have to be something to do with the logic in our toggle facing direction. So we'll just double click into here and we'll have a look at what's going on. So if we're coming in, we are taking the current direction, and I can already see the problem. Okay, so because we have this kind of oddity that I mentioned earlier, at least I think that's what this will be, because we have the enemy potentially facing the opposite direction from when we move, as soon as we begin play, we are potentially flipping this. So that would also make sense why it only happens when we're moving in the rightward direction, because we've already applied a multiplication based on the current scale of the sprite. So because we're taking that into context and flipping it that way, what I think we're doing is we are multiplying a negative by a negative in some cases, which isn't changing the direction that we need to go. So if we throw in an absolute node here, so we still want to get the value, but we'll make sure that we're getting the absolute value returned. So that would mean that in the cases where that's happening, we should be getting a negative multiplied by a positive and then still flipping that in the correct direction. So yeah, there we go. We could see that was the problem direction before. And there we go again. So just double check a few more times. We'll let this hit all of the different walls. Okay, so the delay time there was maybe a little bit too low because we were able to quickly change. But I mean, that made it look as though it was interacting with the level quite organically in a way, where it flipped, but then flipped straight back around and carried on. So I think I'm going to keep that in. That smaller delay seemed to work quite well there. A little bit of a toggle. We could have possibly had it so that it's a little bit longer, but the main thing that was the absolute value, just a problem there. So that wasn't an issue to begin with because we're only ever hitting one wall, but once we've flipped a few times, we want to make sure that we're taking into account the correct multiplication here for the some of the cases where we may be taking this already moving right, because we've had to flip this at the beginning because technically the sprite is facing the wrong way to be moving forward to begin with. We just want to make sure that this is updated to account for that, and with that seems to be working. So we'll just double check how this works when we hit the far wall. And there we go. We're left in a kind of infinite loop. I think this is more of something for us to fix in the level design here, or the placement of the bat. I think that looks better. So 0.2 delay. I think at least making it go between at this point and this point looks better than having it flip and then go up and over. Ideally, what we're going to do anyway is we're not going to place it somewhere where it can get into that issue. I would place it directly in line with this. So now, even if it hits that, we're going to go between these two walls. And in fact, we could keep one here and let's put one down here. So we've now got multiple enemies in the level. And again, this way you can see they're not really having that issue. They're all going to be hitting things pretty much face on. So that, I think, is going to be a pretty good fix. With that done, we're pretty much ready to jump into the combat situations between the player and the enemy, the causing and taking damage between the two different classes. The only thing that sticks out is we've already done our overrides for the enemy class. So we have our enemy died functionality in the bat class from the base class. We just want to double check that the enemy bat has health as well. So again, we've set this to 100 default in the base class. If you want to change that here, you could change that to be overridden in each custom class, each custom child class. by overriding the default health. And remember, we leave the health alone, as that will be getting set in the construction script through the call to the parent class before we actually enter play. So if you wanted the bat to have very low health or something, then you could change that here. But with that done, I think we're ready to go now and start looking at how we can get the player and the enemy to interact with each other. Before jumping back into the player class to get some of the damage between the enemy and the player itself kind of hooked up and working, I realized I kind of brushed over one thing which may have left some of you wondering why we were doing a certain thing in our facing direction toggle. So inside of this function, we've just seen that we needed this absolute value to multiply the current scale from the scale that we want the target scale to be. You may have just thought that this was slightly overcomplicating things, and it is. You've probably seen that the very easiest thing we could have done is simply plug this in. So if we're moving right, we're going to set the scale to be one thing, and if we're moving left, we're going to set the scale to be another. But what I kind of forgot to mention a moment ago is the reason I would do this, or the reason I've set it up this way, is if you imagine a game like Mario where you may have kind of a super power which will scale you, or the way that the health system works, even you've got mini Mario and then bigger Mario. We may do this by simply changing the scale of the sprite. We can also do things like animation. If you don't have the frames drawn in to add squash and stretch, you may be doing something where you're animating the scale to compress it when you're jumping and kind of squash it when you're landing. So the reason I'm doing this is we can account for those updates. If the sprite is ever being changed during an animation, during a power, we're not forcing this to be 1 because we may have doubled the scale of our sprite. What we're going to do instead is we're going to find out what the current scale is. So if we've doubled in size, then we're going to multiply this by either 1 or -1. So we're still getting that increased or decreased scale of our sprite. We're taking that into account and multiplying it together to flip the scale over. So of course, if you know that that's something you're never going to do, if you're certain that you're not going to be playing around with the scale of the sprite or whatever it is you're using this logic on, you can very safely then just plug the return of your select node into the scale and work it that way. Just something I wanted to mention, as I just realized that could be a little bit confusing and left people wondering why we're not just doing it that kind of more manual and hard-coded way. With that addressed though, what we're going to do is jump over to our player class. We're going to start looking at recording the direction at which we've been hitting things or have been hit. And depending on how this is recorded at the time of impact, we're going to either decide whether the player should be taking damage or providing damage. Now in this case, to simplify things again, I'm going to put all of this in a single class. So we'll have the player completely in control whether the damage is being applied, received or dealt. Again, in a larger, fuller project, you may want to have something like a damage class, a damage notifier, some communication between the classes, but we're going to try and keep all of the logic in one place in this instance. So the first thing we need to do, very similar to our bat wall detection setup, we're going to get the capsule component. For any colliding that is kind of recorded in this class, we're going to use the on component hit, as we know that these are blocking each other. So these will be hit events, not overlap events. And the first thing I want to do is cast against the other thing that we're hitting and check that it is a type of enemy that we've hit. So we're doing that using the cast to BP underscore, and I'm going to use the enemy base rather than enemy bat. So again, if you ever created subclasses of that base class, it means that that will account for all of the different inherited enemy types. With this cast checked, if that's true, so if the thing that we've hit is an enemy, we're going to need to do some things, checking some variables and working with the data based on that class as we go through. So what I'll do is, rather than constantly pulling from this pin or this pin later, we're just going to promote this to a variable now. This also saves us the potential of needing to recast as well. I'll give this one a name. I'll just call this one hit enemy ref. And then from here, we want to start again pulling from some of this hit information. So we're going to split the structure pin for the hit, and we want to find some information about the direction in which the hit has been provided. So rather than falling back on the hit normal that we've used in the past, I'm going to show you another way that you may see this kind of calculation done. It's some very simple vector maths to find or determine which direction a collision or impact has been detected. So it's very, very simple. All we need to do is we're going to get the location of ourselves, or in this case, the location of the thing that we've hit, and then take away from that the location of ourselves. The value returned from that vector calculation is going to be the direction in which the hit occurred. So we have that information here. We can see the hit location, so that's the first part of the calculation. I'm going to pull from this and get the vector minus a vector, and then, as I've mentioned, the second part of the calculation is our own location. So we can pull from this pin and we can just search for the get actor location return value. It's nice and simple. So this is going to take the world location of what we've hit, take our location away from that, and of course the returning value from that will be the direction in which we've been hit. Now let's do another debug though. Let's print string this because this isn't going to be very readable, I suppose, or make it very easy to work with this value. So in the print string, we will just drop this down. We'll increase the duration here so that we can see why this may not work, because we want to find from this information, from the direction we've been hit, we want a kind of simple value that we can always test against, that we know will be within a certain range. And basically we're going to be looking to see if the hit has been detected from below the player or has been detected from the side of the player. If it's below the player within a tolerance, then we know that that will be classified as causing damage to the enemy. So we're going again for that kind of Mario-esque, jumping on something's head will cause it damage, and if it walks into the side of us, then that will be classing as damaging ourselves. And we'll see when we test this why this may not be the kind of value that we want to work with straight away. Okay, so we can see here I've hit a few things. You've probably seen what's happening in the background is we're getting some pretty big numbers returned. What we really want to do is, again, we're getting very familiar with kind of working with normalized values, so between a range of 0 and 1, which is kind of what I'm trying to point out here, is we need to always remember what 67 would be in relation to the x-axis. Is that going to be 67 degrees, or is that working in the scale of something? So what we're going to do is we're going to class kind of the bottom of this as being 0, and then we have a degree of between 0 and 1 to the side, or between 0 and -1 to the other side. As an example, that's really what we're going to be looking to do. So the way that we can do this is, rather than using the number directly, we're going to pull from this vector structure here, and we're just going to normalize this value. This will give us something very similar to what we had with the hit normal, where it's between 0 and 1, depending on the direction that we're having this information provided. The main difference here is when we plug this in, I'm going to give this a tolerance of 0. And the main difference you'll see here is that when we're doing the calculation this way, we'll be getting the calculation relative to the player's actor. So the thing that we're controlling is the direction we're going to see the hit from. So we should be expecting to see a minus number if we're jumping on top of something, and a positive number if it's hitting us from above, or if we jump into it with our head, and vice versa. We can then tell whether it's hitting us from the left or the right very, very easily. Whereas with the enemy bat, what we were doing is this hit normal was actually returning the direction the object that we hit was facing, if you remember that. I'm going to jump back in now. We'll press play. That will clear the debugs. And this one's a little bit too high for us to hit, but we can see there that is as expected. We've hit from below, so we're getting a minus value on the Z, and we hit that one from above. It's a little bit hard to get all of these working. So we can see we've got another useful thing on the floor here to see is that we're getting minus 0.15 when it's hitting us slightly from the side on the Z-axis, and we're getting our between 0, so if we let it hit us from the left, it's almost -1, so we know that's from the left. And if we get hit from the right, then we are getting almost +1. So what we want to do is work out this kind of tolerance where we can now jump on it. We can see that as I jumped on the head of the bat there, we're getting almost -1, or just I've got exactly -1. So that would be the ideal point to apply damage to the bat and class that as our damage zone for the bat. We also want to take into account with these values that we can get now, where we want our range to receive damage would be as well. So we can see we're getting a lot of different values here. Some of them may be just between taking and receiving damage. So that's what we're going to do in this step. So that's all we needed to do to get our location though. We now have the information to work with. What I'll do is I'll promote this to another variable, and I'll name that new variable hit direction. Again, we're going to need this for multiple calculations as we get further and further to the right of the nodes. So to keep things nice and tidy, stop loads of wires going everywhere, we'll just be promoting these to variables as we go along. This one, I'm going to put a comment around just so we remember what this is doing. So nice and simple, just to remind us this is getting the calculation from which direction we've been hit. And I'm also just going to grab these and move this down a little bit, as I know that we're going to need some branching logic to decide what we do with the enemy when they're hit, or the player when they're hit, depending on the value being returned here. So from here, we're going to do our branch check. And this will be where we first split the logic to see whether we are providing or receiving damage. And the way we'll do that is we'll get our hit direction. We'll split the structure pin. And the easiest way to check this is we're going to base most of this off of the Z-axis, And we'll see a very simple one to begin with. We'll tweak this value as we go through. But for now, we'll check whether this is less than or equal to exactly 0. So we can leave this for now. This might need some tweaking as we go along. So if we get that value returned, then what we're going to do, this would be classed as the damage to the enemy class. So we can pull from here. So if this is true and we get that value returned, this will be classed as the damage to the enemy. So I'm going to very simply from here, pull from the true execution pin, search for the apply damage. Remember, we don't need to know what class this is applying damage to. We do already have the target though, so the damaged actor in this case will be our hit enemy. The damage amount, in this case, I'm just going to want to guarantee that we kill the enemy, so I'll pull from this. I'll search for get health. So a little bit of a cheating way to do this, but we're just going to pass in whatever the enemy's current health is as the amount of damage to apply. This at least will let us very quickly test this. Now there's going to be a few things that I want to do on top of this, but we've got the death system set up in the enemy, so this should kind of work as we go through and test. There we go. So we've got one enemy disappearing, and if we hit this one from somewhere above, less than or equal to, remember, so we've got a very broad kind of range there, then we can see that the damage is being applied to the enemy and they're being destroyed because we have that functionality in the enemy bat class, just here on the enemy died. Now a few things I want to do before this, and this is kind of that polish and refinement step to the impact system that we're going to have. Again, when you look at things like Mario and Sonic, we'll keep falling back on these quite a lot. They do some simple things, which is they'll take away a momentary kind of hit of momentum, maybe stop the input for a very small millisecond, and they'll apply impulse so it looks as though you're bouncing off. Because at the moment, we're going through these, and as we go through the enemy, it doesn't really feel like much has happened. It just kind of feels as though they're disappearing, and it's almost hard to know whether that was due to what we're doing, if we've actually interacted with them, or if they've just popped out of existence. So what we're going to do, there's a few things we want to account for to begin with. So the first thing is the velocity is always being tracked in the character movement, and I think because this isn't physics-based, this may not be an issue, but just in case we change anything in the future, we're going to get the character movement and set the velocity to 0. So very simply, getting how high the velocity is being tracked in the character movement, and whatever that is at the moment, we're going to set that to 0. I think the more important thing for the way that we have our character set up is we're going to drag again from the character movement, and we're going to stop movement immediately. So this will take the input that we've currently provided, whether we're going left or right, zeroes out the velocity, and stops any form of movement being tracked in the character movement component. So this is going to give us that momentary freeze. And then the final thing, before we destroy the enemy, I've said we're going to add some impulse. So again, I'm going to Control W the character movement, as we'll need this again. I'm going to pull from here and call the add impulse function. So I'll just hook these up in between. To ensure this does something, we're going to need to tick the velocity change. And just to show a very kind of extreme response to this happening, I'll add something like 500 units of impulse to be added to the player when it bounces off of the enemy head. Oh, there we go. So I kind of touched that from the wrong spot, but you saw that we got the impulse upwards there. So try and do it with this one. And there we go. I mean, that actually looks okay. I thought that was going to be a bit more extreme. 500 looks as though it could be a pretty good value to go with there. So we're stopping that momentum that we have. We are pausing the character momentarily and then applying that impulse upwards. And in fact, I think that looks pretty good. I was going to do something more complex with this, taking in the direction that we've hit things from, adding an impulse or knockback. But I think for now that looks pretty good as a response to jumping off of the enemy's head. So with that, I think this is one section almost wrapped up. So we'll put a comment around this just to, again, remind us what this is doing. Very simply, I'm just going to say that this is the logic accounting for what happens when we damage the enemy. Now, a couple of things have come to mind here. Something that we might want to do similar to our enemy bat. We're going to, first of all, throw in a do once node somewhere here. So we're not making sure that we're not repeating this over and over. And another thing is we want to make sure that we're tracking this less than or equal to query here. Now at the moment, I'm kind of guessing at what we're working with. A very simple thing that we could have done is left that print string in. And each time we hit something, when we're testing different things here, we can kind of make note of what feels right, which would have classed as something we would have felt as kind of over lenient for classing as the player to cause damage, and which of those may have felt better to be a receiving damage from the enemy. So I'm going to pull from here and we'll do a print string. And very similar to before, I'm just going to set this to be much higher for the duration so that we can read this a little bit better. And what I'll do is I'll pull in the hit direction, split the structure pin, and rather than getting the whole information, because that looks a little bit cumbersome on screen, we're only really interested in this stage in the Z-axis. So we're going to plug that into the Z. And like I've said, once we've done this, we're just going to make sure that we only do all of this once. And I don't think we'll even need to reset this for the moment, at least for the time being when we're just testing. This means we'll only be able to test against one enemy, but that's perfectly fine. I mean, if you wanted to, we could, whilst we don't have everything set up and ready to go, we can always pull from these. So if this is true or false, at this stage we'll always reset this, and we're just going to unhook this later because, of course, we never want this to be sort of production-ready code that we'll be working with. So we're going to come in here, and we can test again. We know this is working, but so 0.12 felt about right, maybe a little bit lenient. And of course, 0.9 is definitely high enough. That is almost directly on top of the bat. So now as we go through, we can test this, we can tweak, and we can start seeing, so let's say value of minus 0.1 could feel okay. So now if we start doing some more tests with the player damage and we find that that isn't being triggered when we feel it will be, then we'll get some information being fed back here that we can work with. So for the player damage, we're going to do some very similar logic. We will once again want to stop all of the movement, so we're going to account for the velocity and the movement from the character movement component at the same time, and also apply some impulse. So we can actually copy and paste all of these down here. I'm just pressing Ctrl W again to copy all of those. I'm going to take this away, so we'll need to rehook this up in just a moment. And what we want to do, I think this is going to be exactly the same. We will want to do a little bit of calculation for the impulse, though we don't want this to go straight up. What we want when the player is damaged, and especially because the enemy has been set to constantly move towards us, we don't want to be in this state where we're having the movement stopped and we'll be stuck in this kind of state of constantly being hit by the enemy, which is obviously going to be pretty annoying for the player. I'm just going to move the bat down as this is very hard to test against. So if we come in and kind of demonstrate what this would look like, I think the bat's got a little bit stuck. Okay, we'll test against this one, that one. So we can already see actually this is at this stage. We've got that stage where I didn't look at what those values were, but we know that this is going to be a little bit too lenient. So I wasn't trying to kill one of the bats there, but I did kill it, so 0.4. And in fact, for now, we're going to skip this do once altogether because that is going to, I can see that will cause some issues. So I'm just going to make sure that the bat's lined up, and I want this one to be easy to test. So we're going to put it down here. Okay, so we don't want the player going straight up, because if we go straight up like that, you can see we kind of get a free kill. After losing a bit of health, we're going to get that free kill on the enemy. So not an ideal kind of response there. So what we're going to do is we're going to make sure that we take into account the direction that we've been hit, and we're going to apply some knockback force. So pushing the player away from the enemy, which is going to give that enemy time to kind of catch up with us and not put us in a constant loop of losing health and being hit by the enemy without having any control over our player. So to do this, I'm going to pull from the impulse and make a vector. The main thing that we want to change here is going to be the X value that we'll be applying a force to. So what we're going to do is get the hit direction. We will split the structure pin here. We'll pull from here and get a float multiplied by a float, and then we're actually going to need another multiply by float. The reason being is we want to make sure we're going in a negative version, the opposite direction from which we've been hit. So we're going to take whatever this was, multiply it by -1, and then multiply this by a value, which I think is going to be roughly the same as our knockback here. So if we set this to 500, see how that feels, and we can come in and test that against the bat. Okay, so that's not going to work because we're being pushed along the floor. We will need some of that vertical pushback as well. So we're going to be kind of pushed up and backwards to make sure that we can get some velocity being accumulated here. And that is pretty much exactly what I wanted. So you can see that there, as the bat hits us kind of head on, push back and up, which gives us that velocity that we need to get away and escape the bat. And it means that we're not going to take multiple hits constantly and be in this kind of state of being stuck with the enemy. So we want to make sure this happens from the other side as well. So because we're inverting that impulse, that is working perfectly. And again, I think that's pretty much the right kind of force being applied to both of them. We get that nice hit from above there. So I think what we can do, because those are working, I'll just promote this to a variable, the 500 that we have, and I'll call this our knockback force. We can change this for different cases if you want, but I think in this state, they all work pretty well at the same value. So I'll also split the structure pin for this one, and rather than using these magic numbers where we might forget what that's actually doing, we can control drag in, hopefully, these values here, which is just not letting me do, and we can plug that in. So we know that what we're doing is we're applying a knockback force as an impulse to the character when the enemy's being hit. So adding these variable names just keeps things, again, a little bit more readable and easy to maintain the code. So final step, we have our impulse calculated now. Final thing we want to do, we are going to, again, Control W, the damage, and like we've done in the past with our test here for the health, remember we had this on the H input, we could essentially just take this actually. This would be a good time to cut the code from there, paste this down here, because we want to apply damage to ourselves again at a certain value. So we'll say 20 is going to be perfectly fine. And like I said, we don't want this to be in the final game, so we're going to remove that. And that's a perfect time to remember to do that. So we can come in, and if we're being hit from the side, we're now starting to lose health. Same if we get hit from above, something strange happened there. So we'll look into that in a moment. But there we go. So from the side, at least, we're getting that damage taken away. If we get hit from, or if we hit them from above, then we're taking their health away. So let's take a final look here. We're going to unhook this now. I think we will hook the do once back up, and we'll need to find a good name for what this is doing, and we'll call that from both of these. So we want both of these to reset that do once. So we'll first of all set a comment around this. So nice and simple, just remind us this is where the player damage is being accounted. This is kind of doing a hit check here. So what I'll do, and in fact, just to make sure that this isn't being updated more than it should, I'm just going to change the direction or the place at which the do once is called. So if this is successful, then we only want to set the hit direction once per enemy that we hit. And if that's the case, we'll create another custom event. We'll name this one reset hit check. As again, that's pretty much what we're doing. We're resetting the ability to check whether we've hit something, reroute node that, and we'll call that function in both cases here. So we want to make sure that we do this on the true and the false. Of course, if we forget to do this once, then we might reset it after the enemy's been damaged, but if we take damage, then that's not going to get reset and we can never take damage again. Make sure we plug this back up. We can probably skip the print string for now, and I think what I found was working quite well, somewhere between -0.25, which if you think about where that is on the player, that's going to be when we're hitting from around this zone on the player. So from the bottom to our kind of corners of the player, that's going to be our sweet spot for applying damage. Anywhere else, we're going to be expecting the enemies to damage us. So we're taking damage there, and that's feeling pretty good. So I think that's roughly how we want this to go and be applied. So that felt like a good spot to take damage. That was me running into them. A little bit too much force applied there. There may be some oddities with the forces being applied, so something for you to play around with and test there. But I think as far as the hit responses go, and where the sweet spots for the applying and taking damage are, pretty happy with those at this stage. Again, all of this is kind of intended to point you in the direction of where you can start looking to create these effects. You're really going to be expected to take this and improve upon what's being covered here and really make it your own with your own kind of health, damage, systems, and the different effects and things being played. One thing that just came to mind actually whilst looking at this is still going to be problematic. This isn't really doing anything. So just a quick backtrack from what I just said. We're going to delete the reset checks here because this is all happening so quickly that essentially, unless the enemy's dying, that would work on the enemy dying, because as soon as that's happened, we've lost our reference anyway, and any false returns there are just going to reset this to be a null value. But potentially having the player hit could happen multiple times because this is happening in a part of a millisecond, essentially. What we want to do is from this, regardless of the response, so before we get into our branch check, we're going to throw in a sequence. And from this sequence, we're going to allow it to run its logic once, check what's being hit against, and then very similar to the enemy bat, what we actually want to do this from is a delay. So making sure that we do have a small pause before another check. And that was what the initial approach that I kind of overlooked here momentarily wasn't accounting for. We want this kind of delay so that for a certain period of time we're not able to take or even calculate new hit results. And then we're going to do the same thing. And this also means we only need to do this once. So we can now do our reset hit check down here, and we can do that just once, regardless of the results here. And again, we can play around and make sure that things aren't happening too fast for this 0.1 of a second to be too low, but I think that's going to be perfectly fine. So I kind of, even then you can see that I bounced on them and it was such a small delay before this gets reset that we still got hit that second time. So I think this is going to be okay. The main thing, as I said, this case it would have worked, this case it wouldn't have worked because that happens so quickly. It's immediately resetting it and we could still get those multiple hits being done per collision check here. With the damage system now fully implemented, we've got the enemy bat taking damage and actually being killed or removed from the world. We've got most of that set up and ready to go for the player. Of course, at the moment, the player's only receiving damage. We're still going to call this default print string, which is just to remind us in the player died function that nothing's been set up. So let's jump over there now and we can start getting this worked on, and we'll consider what needs to be done for the player died scenario and how we can implement this. Okay, so the first thing is we know we're already tracking this B is dead value, which is going to be quite important to us. So we'll delete the print string to get started. We will alt drag in the B is dead, and we'll just be sure to set this to be true. So again, that we know that all of our checks or whether or not we should take any further damage is based on this. We can actually remove this from here. We don't need to do this twice. This would probably fit a little bit more nicely inside of the function handling the player dying now. But this means that this is now tracked and we won't take any further damage, and we won't play this response that we're about to set up now more than once. So inside player is dead or player died, we're going to set the boolean here. This is just, like I've mentioned, a little bit cleaner. Now the first thing I think I want to do is take the input away from the player, so we don't want them to be able to carry on running, add any kind of final input to this. So the very first thing we're going to do is call a function on the player controller. So we use the get player controller and we'll call the disable input function. Just make sure that this is hooked up to the right place. So the player controller is going to be the player controller target, and the actual target for the input to be disabled is ourself. So now when we die, this means that if we're pressing forward, backwards, or anything like that, we won't be able to jump or move in any direction. And again, this is very simple to test. What I'm going to do is come back to the damage, and we'll promote this to a variable as well, the base damage for when the player is damaged. So if we promote this to a variable, we can change this from anywhere, which will again just make this a little bit easier for us. And I'll just call this one player damage. Now, ideally, we're going to change this based on the thing that we're hitting, but again, very simple project to get things going. This can be easily changed later, but this will just allow us to now very quickly change this to 100. And it means that when we're working inside of our player died function, if we ever want to test this now, we can come straight into the game, get hit by the enemy, we can see we've died. And now if I keep trying to move, jump, movement, everything like that is disabled. So first check is done here. We have this bit working. So if you remember previously, I mentioned that I wanted to replicate again that Mario or Sonic retro kind of 2D death animation where you fly up into the air and off of the screen. So we already have something very similar working, but instead of using the character movement impulse, this time I'm going to move the whole thing. So we're going to take the capsule component, and as this is the root component, obviously everything is kind of nested below this for movement. We're going to grab that and add impulse to that. We're also going to have to remember to disable all of the collision to allow us to merge through the floor. So if we control drag in our capsule component, we can, first of all, to allow us to do this, we need to set the set simulate physics to true, and we'll just hook this straight back up. If we didn't do this, we're going to get a warning when we tried to do anything like adding forces or impulses to something which by default doesn't have the physics simulation enabled. We can see here, simulate physics is set to false, which means if we try doing anything physics related, we get a warning or an error kind of message come up. I'm going to press Ctrl W to get the capsule component again, and now that we have that in place, we can pull from here and we'll make the add impulse function. So very similar to what we did through our character movement component, we can do the same thing here. We're going to set the velocity change to true. We'll split the structure pin here. And I'm going to make the impulse this time a little bit more dramatic. So we'll set this up to something like 800 or maybe 900. So it's clearly higher than just being hit. So again, if we come in, press play, we can test this. and it's not quite working. Remember, I've mentioned the other thing is the collision, so I think that's going to be high enough. The problem is we were immediately kind of punched out of the air because we're still taking in our hit responses. But I mean, this is fine. We get some funny results from doing these, and we're testing that things are working and how they're responding as we go along. So we're just currently rolling around. Not quite the response that we want, but we're definitely getting closer. Now, again, we want to make sure that all of this is being accounted for in the right direction. So the first thing we want to do, we don't want all of these to be played potentially before we've disabled our collision. So I've just made a bit of space here. I'm going to Control W the capsule component again. Again, this is just to save wires going from multiple places. This starts looking a little bit messy. I'm going to pull from here and we're going to set the collision response. We can set this to all channels. We're not going to need to worry about this missing anything because, of course, at this stage we're dead. All we know is we want this to ignore collision responses on every single channel. By channels, if you're not familiar too much with the collision settings, we've got the collision presets. These are the channels. We've got tracing, overlapping, and block, and the different things that we can either trace, which would be things like raycast to check casting into the world if we've hit something, or are looking at something, overlapping for things which won't block the other object but just detect that you've entered the same space, and then blocking, which is what we're doing, where we're physically moving things or potentially hitting them with an almost physical response. So we're going to set all of these to ignore, so none of these will block anymore. You can see most of them are set to block. We'll set this to ignore, which means we'll also start doing things like falling through the floor. We're not even going to respond to the floor's collision response, which is ideal because remember I said part of the setup is making us fall out of the level. So we're jumping up and then falling through the floor. So that is pretty good. We can see again more issues here. So what we're getting a problem with now is the camera is colliding with things that we didn't have problems colliding with before. So what we want to do, if you wanted to keep the camera attached and stop this from happening, we're going to go to the spring arm and we can see we've got the do collision test enabled. And basically what was happening when it was flickering, the spring arm, remember we've got this long arm here, is trying to adjust out of the way if it's tracing into the world and detecting that there's something that we could potentially be colliding. So it's noticing that we're now clipping through this and it's trying to move the camera, which is why it looks a little bit jerky. We can stop this by unticking the do collision test, and again we'll try this again to see the new results. So what we should see now is we're still going to merge through ourselves, but that's fine. We can change the Y offset or something if we wanted to override that, but the main thing is we don't have the camera jumping around. Generally though, this is going to kind of show that we don't have an entire level around us. This isn't what you would be used to in those kind of old school games. So what we're going to do instead, that is just one fix. The way that I'm going to approach this is we're going to grab the spring arm component. We will pull from this and we'll use the detach from component. So this already knows what component it is attached to. It's attached to the capsule component, as you can see here in the hierarchy. But this is going to take the spring arm. It will detach from what it is attached to at the moment. It's going to keep the location and rotation. We might need to update these and it will stay where it is in the world. And this is more what you were used to seeing, is the player kind of flying up and out of the screen. So this is relative. We don't want this to be relative because it is currently relative to the capsule component. We want this to keep its position in the world. So not where it was relative to its owning component. If the spring arm is moved over here, we want it to stay over here when the player dies, because you saw that kind of flew down to the corner of the screen. And there we go. So we now have the player jumping up, the camera staying where it was, and we're avoiding all of that clipping issue. We can still kind of see the players going through the floor, but again, in this case, not overly important. If you wanted to, when this happens, you could do something as simple as you could add a very small impulse on the Y. So if we just add an impulse of like 1 or something, this will put us slightly ahead or behind of the floor. The enemies have disappeared. That one didn't kill me. And there you go, a very small impulse. And again, if you wanted them to fly behind the floor, and you can see that the difference there is that he fell behind the hill. And if you wanted, you could get slightly creative with this. You've seen how to add different offsets. Again, using a select, you could add something like a random Boolean select, and 50-50% of the chance you could get them to fly forward with the select node here. And same for the X. If you find it boring that they're always just going straight up and straight down, you could add a random chance for them to fly left or right. And the final thing is I've been doing all of these tests when I'm stood perfectly still. If we're moving towards the bat, you can see something strange like that happens though. We get a little bit too much force with different forces being applied to each other. So I think what we need to do before all of this happens, we're also going to stop that movement. So we'll disable the input and stop the movement that we have. And just to say, going back to this very quickly, if you wanted to apply different impulses to the X and the Y and apply that randomly, then I'm not going to go through that at this stage. We've done very similar things multiple times. This would be a good kind of learning test for yourself between topics. Just give the videos a pause and see if you can implement this yourself. Take some of the select nodes that we've been using, some of the random check, put those together, and you pretty much have the result for some random impulses here. So the next thing with this stopping of the momentum node, we already have this being done. We're already copying code here, which is never ideal. So what we're going to do, probably familiar with this now as well, we're going to select two of these, we're going to collapse this to a function, and we'll name this one cancel movement. Of course, we're going to delete these down here. We can drag in our cancel movement and we'll just hook this up to the false pin. So we're doing exactly the same thing. Now the impulse is slightly different. We could pass in different overrides if we wanted, but I think in this case, these two are kind of unique enough to not warrant dropping this into a function. I think that would be a little bit more of a hindrance to our code progress than it would help us. But in this case, we can take the cancel movement one more time, go into player died, pull from here, find the cancel movement function and hook these up between the two execution pins. And this just means now, if we try this again, what we should have is that movement cancelled. We can say that's not the case, so this isn't picking up velocity. I think the problem being is that we're not getting velocity from the character movement. I think instead we're getting velocity from the capsule component. So we can either replace or just do a kind of fail-safe and zero out both, which is the option I'm going to go for. And what we want is on the capsule component, it's a slightly different name. It's the linear velocity. It's the all physics linear velocity that we're looking for. So the easiest way is just to type linear, slightly long-winded. So we want to set all physics linear velocity to 0. And then we can try this again, and I think that should solve everything now. So if we go and find the bat, yeah, there you go. So we're getting rid of all of the movement. The velocity was actually being calculated on the capsule component, not the character movement. But again, there may be cases where this changes. So just in case, I'm going to leave this in. But we can see that now, regardless of how we're moving, it's going to cancel that out, and we're going to apply that force. Just the force that we wanted though, which is that vertical velocity to replicate that old school dying animation. So that is pretty much everything. You can, like I've mentioned a few times now, you can come in and really kind of start polishing this up. Another thing you may have noticed is that when we die, we're just entering the jumping and falling animations because that's what's being tracked. We don't really have anything as a death animation, so if you wanted to import one, you could bring that in. And like I've mentioned, adding new animation states should be as simple as adding a new movement state, which is our enum that we've exposed here. You could add after the jump before, you could have a death animation, and then adding this to be tracked. So again, as simple as in the player, update Flipbook functionality. Check here. You could even do another branch entirely. So rather than adding things on to this stream of logic, it could be as simple as if player is dead, then play the death animation or stop all animation. If it's not dead, then continue to check which movement-based animation we should be setting, and then just adding that extra pin in here for the death animation. So again, just to recap why we've gone with this kind of automated approach. It's not fully automated, but you can see how much easier it is to plug in just one new movement state than it would have been to have an extra set of branching logic to the side. So between the topics, again, if you wanted to pause and do that type of thing, just for that kind of refined polish, then do feel free. It's not something that we'll be adding in the topics, but that does mean at this stage, we're now done with the enemies and the player. They're all interacting pretty much as expected and as we wanted them to. We can now move on to the final topic, which is going to be the interactive classes, the pickups to replenish health, and that spring item to act as a kind of jump pad and provide a slightly more interesting level to maneuver around. To move on to the interactive classes, we'll be looking at this in a very similar way to our enemy classes. So we're going to have a few different types of interactive classes in the project. Therefore, we can derive a lot of the general logic from a base class. The difference here is we're going to have multiple interactive classes where we only have the one enemy. We have the Flipbook ready for our heart and spring. So we know we have two classes available. And of course, you can expand this out. To get started, we will just make sure that we keep the project hierarchy nice and tidy. So we're going to create a new folder named Interactives. Inside of this, we'll be creating our main classes. So the first one is going to be our interactive base class. And of course, all we really need this to do is exist in the world with the potential to interact with the player. So for anyone familiar with Unreal, you're probably already aware that as far as the class hierarchy goes, or the class structure inside of Unreal, the most basic type of class that can exist in the world with a transform and that kind of physical entity is an actor class. So we're just going to come down, create a new blueprint class of type actor, and I'll name this one BP_interactive base. Like I've said, inside of this class, this is where we want to take those considerations, so the things which will be generic between the different potential interactive classes. For this project, I can only see two different variations that we'll be having, and between those, there's only two things I can see them needing to do. One is going to be more of an issue with the way that the Flipbooks are set up, so a kind of workaround to that, and the second is the actual interaction. So we're going to need some type of collision for the player to cause that interaction to be fired off. And the issue comes from the fact that Flipbooks are automatically set to play and loop. So we're going to need to account for that because the heart is going to look pretty good looping, but I think the spring, of course, we don't want that playing constantly. First of all, if we consider the components that we'll need for this, all we really need is the visual representation for the animation and the colliding actor. And I'm going to separate these two out, or the colliding component, and I'll separate both of these out so that we don't need to worry about providing a per sprite animation on the animating flipbook. That would be some potentially extra performance calls that we don't need. What we'll do is we're going to encapsulate the entire flipbook inside of a cube collider. So for the components to begin, I'm going to add a new scene component. Just going to drag and drop it on top of the default component or the default scene component. This is purely so that we have like an anchor point and a transform for the other components to sit on, but we don't need that spherical billboard representation. So we're going to get rid of that with a scene component. Then on top of the scene component, we'll place our paper flipbook. So this will be the animation for the different sprites. And then making sure that we have the paper flipbook selected, we can use the drop down again and find a box collider. So this will be the thing that the player will potentially interact with. And I'll just give this one the name of Interactive Collider. This will just make it a lot more kind of easy to update again, come back. It's going to be very clear why we have a paper flipbook. It's a 2D game, we need that visual representation. It might not be so clear what the collider is doing. So if we name this accurately now, it will make things a little bit easier when we come back to the project. So the first thing to account for will be this collision setup. Looking at the paper flipbook to begin with, we can see that the collision channel is set to block all. So if we were to add a flipbook here and it did have some collision information, then this could potentially, again, taking into account things like the spring component, when we add that in, that would potentially block the character from moving. Rather than adding that impulse, it may actually stop you from moving around the level. What we'll do instead is we'll drop that collision preset option box down and we'll change this to no collision, so this will not collide at all. It won't provide any collision costs, and we'll also make sure that we untick overlap events just in case anything changes. So all of the collision is going to be done from our interactive collider. If we have a look over here, we can see that this is set to overlap all dynamic, and we can make this a little bit cheaper if we just consider how we'll be using this. So at the moment we can see the object type is a world dynamic type itself. So this would mean at the moment that other interactive classes could potentially overlap with each other, as they would with vehicles, anything destructive. It could be things like, I think the enemy classes are probably world dynamic as well, so this could be triggered by an enemy. So what we want to do is we're going to change this to custom from the drop down here. I'm going to tick this button here, the ignore, the top one. If you tick the top row, it will change all of the options underneath. So we're going to make this ignore everything except the pawn. So the thing that the player is controlling is the only thing we want this to interact with. So this means now that anything else in the world won't trigger this functionality. We'll make this a little bit cheaper to run. And it also means that we don't need to consider so many different eventualities with the collisions. Okay, so that is our components setup. We can now move over to the event graph. As we've done in the past, a few things that we can do here. We can get rid of the functions that we know we won't be using, which will be these two. And we only really have those two considerations that I've mentioned that we want to do or account for as a generic functionality for all of the potential interactive classes. So the first one I think we'll address is that fix. So the way that this works, we'll just hop back into the viewport quickly. If you're not familiar with this, if we select a sprite for our flipbook, we've got the hearts and we have the spring. So when we place this in the world, this will do exactly what we have here. This will kind of pulse and pump with the heart, which I think looks pretty cool. In the context of kind of fleshing out your world, it's quite nice to have these animated Flipbooks and Sprites. Having things like foliage moving around, the enemies pacing back and forwards, the pickups kind of animating in this kind of pulsing way here, brings your level and makes the level really feel lively and brings it to life. So this isn't something I want to cancel out altogether. However, if we then consider the FB spring, of course, we don't want this constantly springing nothing as we're just walking by it. We want this to only react, so this is going to be very reactive, which is why we've removed the event tick. And we want this one to only react and play this animation once when it's actually adding impulse to the player. So this will be the first thing we fix, and I'm just going to undo this. Like with the enemies, I want to make sure that if we ever forget to change this in the derived classes, it's very clear that we haven't given this a flipbook, because they won't be showing anything. So what we're going to do is we're going to pull the paper flipbook, we'll control drag this in. We're going to pull from here, and we're going to search for looping. So we can find two things here. We could have just searched set looping, or we can check if it's looping. All we're going to do is immediately on begin play set whether or not we want this to loop. Hook this up to the execution pin from the begin play. Then the new looping, I'm going to select this and we'll promote this to a variable, and I'll just name this one B autoplay. I'll make this public as well and compile this and just make sure that by default, let's assume that we want everything to autoplay, and then we'll come in and we'll change this for the spring class. So what this will do is this will come in and it should check if it should carry on looping indefinitely or whether just it should be a kind of play once type of sprite. We've made this public so that if we ever wanted to override something for any reason, maybe we wanted a very special type of heart pickup that doesn't animate for some reason, then we could easily change that from the world outliner. Just here, when we've dropped it into our world, we could select it over here as you've seen on other public properties. So that's the first part of the generic logic I think we'll need to be doing. The next thing is we're going to need this new function, which will be a thing that happens when we interact with the player. I'm going to create a new function like we did with the enemy base. I'll name this one interact. And very similar to the enemy base class, we're not actually going to do anything in here. Instead, I'll just set myself a reminder with a simple comment saying that the functionality is intended to be overridden in the child classes with their own kind of unique functionality. Now, one thing that, because this is going to be very simple, you could extend this if you wanted by changing the interactive collider setup. You could have this interact with things like enemies. So if you wanted to implement systems where enemies could use the springs, or they could potentially pick up health and share that kind of health pool of items with the player, so it would give the player some extra kind of challenge to make sure that whilst damaging the enemies, they're also not recollecting health somewhere else. You could easily change this to be accounted for. But in this project, what I'm going to do is I'm going to assume that we're only going to be interacting with the player. So for the input, so that we have access to all of the health information and things like that, I'm going to create a new input here. I'll change the variable type here to be the BP underscore player base object. So we're going for this object reference. And I'll name this one the player ref. Now we're going to use this in just a moment, so we'll make sure that we compile this and save. And that is pretty much everything we need to do for our interact function. Back in the event graph, we're going to get the interactive collider, and we want to go down here. Remember, we're doing the overlap events, so the overlap's not the hits. The hit is what we were using in the enemy classes. The main difference being is that hit events act like a kind of a blocker. So if you remember that the collision needed to be resolved to the stage where the player was pushed out of its line in the y-axis and it was pushed to the background. In comparison, when you're doing overlaps, you can have two things pass each other. They're not going to physically stop each other, but we can have an event fired when an overlap is triggered or noticed, and that's using the on component to begin overlap. Now, we're not going to need all of the information like we have in the past, but what I will do is, because we want to call our interact function and we want our player reference, even though we know that the only thing that we should be colliding against is the player class, I'm going to do one extra check here. So we're going to cast this to the type of BP underscore player. See, we've got the BP underscore player base, and that way the interact function will now only ever be called if this is a successful cast, so if the thing we hit is definitely the player, and not only that, but we can then pass in the reference to the player base, which means again, when it comes to adding health, adding impulse, we have some information that we can use about the player. And that's really it. So this is the base class done. This is the generic functionality that the child classes we're about to create can all inherit and reuse very simply. The first class we'll get started with, we can leave the interactive base class if you're still here. What we can do now is using this, we can derive another class from this, as you've seen with the enemies. So we're going to right click on the interactive base, select create a child blueprint class from this, and I'll name this one BP_interactive health. A few things obviously we're going to need to do first of all is make sure that the components are set up as we need them to be inside of the child class. And all we really need to do is we can select the paper flipbook and set this to be the health flipbook that we have already. And then we need to make sure that the interactive collider fits pretty snugly around the image. So I think a box extent of 25, 1 and 25 should work pretty well on that. So we don't need anything in the Y to be very deep. And it's pretty much a square image, so a 25-25 radius seems to fit it pretty well. Next, we don't really need to do anything. Remember, we could set this if we wanted it to not play. We could set the autoplay to false. This would take effect in the event begin play. If you wanted that to happen sooner in the parent class, you can always put that on the construction script, but I think the event begin play should be perfectly fine for now. The only thing that we're really left that we need to do is add that health functionality to the player, and that's going to be done through our override function. So if we drop this down, we can find the interact function here. All we want to do is work out a few things to happen on the interact event. So this is going to be fired as soon as the parent class function of the overlap is triggered if we hit the player. So we have the player information here that we're going to need. And there's a couple of things to consider. So you can probably see how this is going to go. We want to add health to the player, and then we want to destroy the interactive health pickup so that it doesn't exist in the world any longer. And just take a moment before we go through this together and consider which order of call that you might want to do this. So we're going to add the destroy here, here, and where we're going to call this health functionality update. Okay, so of course we know that the first thing that's going to happen is we can account for anything happening on the parent call if we wanted. So if we added the destroy call here, of course that's going to happen before we can even call the parent functionality. Now in this case, nothing's really happening on the parent functionality. So we can either remove this altogether or just plug this in and do everything after this. It really doesn't matter in this case because I know that we're not going to be going back to the parent class and adding any base functionality. So in this case, I think what we can do is we'll just show how we can go through this process without even making a call to the parent class if we don't want to. So next we have the player reference. And a handy little tip here, if you haven't seen this before, because this is now a local variable, for as long as we're inside of this function, we can search for the variable by the same name. And rather than pulling this from everywhere like we've seen in the past, we want to really avoid having wires going everywhere. We can just use the getPlayerRef node just here. That's exactly the same thing, but this means that regardless of how many times or where we need to call this, we can reuse this variable very, very easily. And what we want to do is see if we have the health functionality set up. So we know that this is the BP_player base. We search for health, we can see that we have the update health function, and we can set the health variables manually. Now we never really want to set the variables from one class in another. This can make it very hard to track where variables are being set and updated, especially if they start being done outside of the player class as an example. So what we really want to do, ideally we'd make these private so we couldn't even see them from another class, but ideally without that step being taken, we want to create another function in the player class similar to update health, but we're going to call this one add health. So let's go over to the player class. Remember that the update health is quite simply just finding what the current health is and updating that to the widget. So we could probably rename this to be a little bit clearer actually. So we'll make this update health widget because that's really all it's doing. What we want to do is provide a function. So we're going to create a new function. We'll name this one add health. And in here, we just want to provide one input, which is the amount of health, which is going to be held by our pickup. So we're going to add a new variable here. We'll make this a float and we'll change the name of this to heal amount. So the amount that we're going to be healed, and very similar to what we're doing on the damage event, if we can find that here. So on the any damage, we're going to want to set our health, rather than being a minus here though, we're going to set this to be a positive. So we can copy a lot of this. I'm just going to copy and we'll paste this into the add health function. So we're going to set our health to be current health, and then rather than using a minus, we'll say plus another variable or another float. We'll plug that into the value and that will be here. So whatever the health currently is, plus our heal amount will be our new health. And again, we're making sure to clamp this so we don't do anything silly by accidentally making it lower than 0, and we won't make it any higher than the default health. So nice and simple, copy and pasting was perfectly fine there. And we've already kind of seen this logic, so we didn't really need to retrace this too much. Now the final thing is we can call our update health widget. And if we do this here, this is going to take in those variables that we've just changed, and this will show on screen the new health amount that we should be showing. So nice and simple, that didn't take very long at all. And that is all of the health system now implemented in the player class. Now a few things I've noticed for cleanliness though, is we have several variables of the same type, kind of all separated and taking up a lot more space than they need to over here. So this can happen in some bigger classes. What we can do to get around this is we can actually put these in different categories. So as an example, I'll select the first Flipbook type and I'll put this in a category named FB. So we can shorthand this, and then we can either drag the other Flipbooks into this, or we can now use the drop-down option and change the different category that we've just created. We can then drop this down so we can see we've saved a little bit of space on the multiple variable types there. And likewise, I'll do the same for the floats. So this is just a case of creating a new category named floats, dragging them in, and then we can collapse those when we're done. Now we've still got a few left over, but I think this will make things much easier to find now, and then those unique types are not taking up too much space. Before we head back over to the health class, just make sure that you compile and save this to make sure that this new function will be able to be located in the other class. So we're going to go to the interactive health class, and then from here, we've now got our reference we're already using. We can pull from this, and we can now find that new add health function. So hopefully you can see why this is going to be a little bit safer. We're now not setting the health value outside of the class where it's being used, which means inside of the player class, just as a recap, we now know that this health function or this variable is only being updated either in the add health function or the damage section of the event graph here. It means that if we're ever kind of debugging through this, we know where to look if something strange is happening with the health. Whereas if you start adding these calls to set variables from other classes, it starts becoming a little bit harder to track down where multiples of health might be getting changed to something at some point in your project. So the final thing is we can set this to something like 10 for the heal amount, and I'm going to promote this to a variable. I'll name this one health value and just drop this down and tidy the nodes up a little bit here. We can also make this public, hit compile, and the reason that we've made this public is now when we drag this into the world, so we'll come back a little bit, we'll find our interactive health, drag this in, make sure that this is on the 0 axis and the Y, or 0 value on the y-axis. And if we drag this and add a few different health components, or health pickup, we can change the value in the editor here by making this public. So again, we can add some variety to these. So this one can be worth 50, this one can be worth 30, and we'll leave the first one at 10. We can now come in and test this. So we're going to want to find an enemy to deal some damage. We've set the enemy to completely kill us in our test. So make sure that we go back into the player class if you forgot to change this back down to something a little bit more manageable. So the player damage was set to 100. We're going to want to set this down to something like 20 again. Compile that so that we don't die immediately. And this gives us some time to test the health value. Okay, so we can see this is being picked up. We can also see the one thing we forgot to do there in the interactive class we haven't fully finished. We can check though that the different health values were working. That all seems pretty good there. The final thing, of course, is once we've interacted, once we've added health, like I've said, we just want to destroy the actor being interacted with. Or actually, no, that was wrong. Don't destroy the actor being interacted with, because the one we're interacting with would be the player. Obviously, we don't want to destroy the player. We're going to destroy ourselves, so that when we come in, we can now add some health, and we can see it's being picked up. Take a bit of damage. And then we can come over and collect our health pickups. We're getting healed, they're being destroyed, so we have a fairly standard health pickup implemented. The final interactive class and the final class we'll be making in this selection of videos is going to be our interactive spring. We already actually have a lot of what we need going here. In fact, we have everything we need going. So what I'm going to do, rather than creating a brand new class, remember that this one, our health class here, is already inheriting from the interactive base, which is exactly what we need. So what I'm going to do instead, rather than completely recreating the wheel, I'm going to Control W, our interactive health, name this one interactive spring, and inside of here again we can see that this will take the same default values as the health, so we're deriving from the parent class of the interactive base, which is the main thing here. We have a variable, so this float variable is going to be very useful in a moment. I could already kind of envision what we're going to be using, and we have our interact function also being called. So the main things that we're going to need are just here. We can rework this a little bit. We won't want to destroy the spring whenever it's used. We won't want to add health, but we will need two variables, which are going to be the player reference. We want to do something to that. And this health value, we're just going to need to change the name, but we already have it available. All we really want to do when the spring is touched, we're going to come in here and we're going to call the launch character function. So again, this is where it's useful to know that we're interacting directly with the BP_player base, because we know it's a type of character. That also lets us know we can use this default built-in functionality in the character class to launch, and essentially just adding velocity to our character class is kind of like a jump, but with some different overrides. The reason that we want our float value, we'll just move this down. We don't want to take in any X or Y velocity, so we'll split the structure pin here. And we can plug this into the Z as the amount to launch the character on the Z axis. We want to override the Z override, so we'll tick this to be true. And we can rename this to our launch force. And like we've seen in the past, we can leave this public. So again, on any of the different springs that we have around the level, we can very easily update and override how much force is going to be applied. I think by default, 20 or 10, even lower, is going to be quite low. So we can start with something around about 500. I have a good feeling for an impulse of 500. It may be too low. We can update that in the level when testing. Now, the next thing is to remember the way that the visuals are going to work. So the visuals, first of all, we want to change the paper flipbook. We're going to change this from the heart to be our spring. And if we just hop over to the viewport here, we can also see that our collider is going to be a little bit small. I think really all I want to change is the width of this though. So we're going to go to the interactive collider, change the width, which is going to be our X, to just about fit this. And then remember that we have a scene anchor here, so that allows us the freedom and flexibility to change the position of the flipbook, or in this case, the interactive collider. Because the interactive collider is a child of the flipbook, of course, if we move that, the collider will move with it. So what we want to do is take this collider and just move this down, roughly to the bottom of the spring. So the idea is if this wasn't playing, it will be sat just above the top of the spring so that it will look like as soon as we hit the top of that spring, we're going to play this animation. So that's the visual side done there and updated. The final thing is back in the interact function. Remember that we're going to set this to also play to be false. So we're not going to be playing constantly in the level. What we will want to do is as soon as we've interacted with this, we're going to set this to play from the start. We do that by getting our paper flipbook. So control dragging in the paper flipbook and then finding the play from start function. We'll just hook that back up and tidy the function a little bit. And that is pretty much all that the interactive spring really needs to do. So again, if we come back into the level here, we probably have too many springs. So I'm going to grab one of these with the interactive spring selected. We can right click on the heart and we can choose the replace selected actor with, and one of the opts is going to be the interactive spring because we have it selected here. So we'll replace it with that. We can see this will automatically change and we can come in here and move this around. Now in the editor, looking at it, maybe this will be a little bit annoying that we have these animating constantly. So back in the interactive base, what I'm going to do is grab this and just pop this into the construction script. So this should hopefully stop any looping animation. And there we go. We can see that the spring has immediately stopped animating. So that lets us know that this is working. It's only going to change if we move the location, but that's better than having it springing constantly. And let's add a couple of these in as well. So we can use one over here. When we get past this section, we can allow the player to easily jump up and reach this section. These are also going to work as good ways to kind of test different velocities and the impulse that we're going to be adding. So perfect, we can see that that didn't animate before we started playing. Jump on this, it's going to animate once. It's not going to go back to looping, we need to kill the bat. And we can jump on this again. I think the impulse is maybe a little bit too low, so it doesn't look as though we're being pushed up quite as high as we need. So we can come in, we can change this to maybe 800, and then hopefully, yeah, so that looks as though it's actually, we're going up with the spring rather than through it, and that's pushing us up a nice distance. So we can go and play with different values on the other one, so we could test maybe what this would feel like with an impulse of 1000. And they're both pretty good, but the main thing you can see is that these are resetting the animation. The hearts are playing constantly, and everything is pretty much responding as we would hope and expect. Hopefully with that you've seen the kind of values of adding these public properties as well, so we can easily come in and change the health values now, the spring values, so we can add some extra launch force. And like I've said, if we really wanted, we could set one of the springs for whatever reason to automatically play and one of the hearts to not play. So when we come in and play now, this one's going to keep pulsing for no real good reason, and the heart is going to be frozen in place. So we have a little bit of flexibility with how our classes are working, all derived from the same kind of base class, meaning that we needed to program a lot of this only once and we can reuse it between different inherited child classes. Now the only other thing that I haven't really touched on is that we're getting a lot of different items coming in over here. So you may want to start renaming some of these, especially consider the way that we changed one of the hearts to be a spring component or a spring actor. It's still named the default name. So we can see it is a spring actor here, but it's still called BP_interactive health. So anything can be renamed here. We can change this to spring and that will kind of update correctly. And we've got the same thing for this one because that was just a copy of the original one, which was already called health. Now another thing you might want to start doing is you can create different groups. So you can add subfolders here. So we'll name one enemies and we'll create another one and we'll name this one interactives. Main reason being is that we can then easily drop enemies into enemies, interactives into interactives, and if we ever wanted to clear things up and just look at the level, do a little bit more level design, we can hide certain things. Of course, when you press play, all of these are going to come back. This is only editor related, and of course it just means as well, you're not going to have this huge hundreds and hundreds of items drop down at all times, especially if you just wanted to find something like the light source, move something around, then it's going to make things a little bit easier to navigate through, and we can drop these down and work with them whenever needed. With all of that done, we now have the basics of a 2D platformer set up and working inside of the Unreal Engine. Hopefully throughout the series of videos, you've come to appreciate some of the power that can be leveraged from Unreal, and although there are some slight hindrances with the Flipbook system, the way that we can automate some of the processes of working with those, and it really isn't that bad. We've still got this really useful tile editing tool, fully compatible with collisions and things that I've not even dived into, like we could set up materials using the default Unreal Material Editor to take into things like normal, so we can add lighting and essentially replicating 3D lighting techniques on these 2D sprites if we had that information available. There's much more that you could do with this, but again, this is really just to bring to light a little bit more that this is definitely more than a suitable 2D engine as well as 3D. All we're really doing at the end of the day is taking away an axis or two, and again, Unreal has all of these things where we can constrain different things to different axes to allow us to really easily work in a 2D world. So if you've enjoyed this content, do be sure to follow me for more content like this. We'll be looking at making bigger, more in-depth updates to similar content in the future. So do be sure to follow me on here for content like that if this was something you found useful and wanted to see more of. So I hope you've enjoyed the series of videos. If you've gotten this far, then thank you for following along with everything and going through the entire process with me. So thank you for your time and patience, and I look forward to seeing you in the future.